astronauts and cosmonauts will come down and we will merge you in the city, and that will be
birinin dışarıdan kontrol etmesi lazım. Geliyor.
that will be your
Birinin dışarıdan kontrol
free time
etmesi
and
lazım.
enjoy the city.
Tamam bak şu an
Any
hareket
question?
ediyor.
That's 12:30 today. 12:30 today. 12:30 today. Departure 12:30 today. Thank you.
Excellent. That was the missing information that I didn't have. So coming back to our cooperation, a couple of years ago, the International Astronautical Federation and representatives of the Association of Space Explorers came together and said, why are the astronauts not members of the International Astronautical Federation? Which would make sense because it's all about astronauts or astronautics, let's say. So in the end, ASE, Association of Space Explorers, joined the IAF as a member, and ever since you can have deducted prices for coming to the International Astronautical Congress that will be held in Baku this year. In order to show this excellent cooperation, we introduced a joint session scheme, which brings us to the International Astronautical Congress with a session chaired by the Association of Space Explorers and vice versa. We have the honor now to have the Executive Director of the International Astronautical Federation, Dr. Cristian Feichtinger, with us, who will guide us through this morning's session to show this cooperation between IAF and ASE. The lineup of speakers will be explained by Cristian, and I'm very happy to welcome him and his lovely wife, to the session. It will be characterized by this Austrian talent to make it light-headed. We know that already. So the floor is yours, Cristian. Thanks for coming, and thanks for taking over the chair of this session.
Thank you very much, Reinhold, for this very nice introduction indeed. Following on what Reinhold had said, we've established this partnership between the ASE and the IAF a few years ago, and this year we've gone even one step further because we have decided to create a dedicated committee within our federation, an astronauts committee, which we will formally induct actually at the IEC in Baku next week. And some of you have been invited to be the founding members of this committee, and I thank everybody who has responded already positively. But there will be space for many more people to join this committee, and I think it will be a great opportunity there to discuss also what we can do together, which events we can arrange, and how we can reflect astronautics in our mutual events at the IEC and at the ASE conference. We will also at the IEC next week in Baku have several events that will involve astronauts. There will be a technical session, as you said, it will be chaired by ASE. We'll also have a global networking forum session on Friday next week, which will be open also to the general public. So there is great interest also in Azerbaijan about astronauts. But now with this short introduction, let's come back to this session today. It is my great pleasure and honor actually to be the moderator of this very prominent session that will show two very prominent speakers whom you know very well, but still I'm going to introduce them, and afterwards we'll follow up with a panel discussion with some more astronauts, space flyers to be on stage. Let me start by introducing our first speaker, who actually wouldn't need any introduction, but I'm still doing it, because it gives me a great pleasure to introduce Michael López-Alegría, whom you know very well as a veteran of 3 space shuttle missions, STS-73, 95, STS-92 in 2000, and STS-113 in 2002. 1 ISS mission with the Expedition 14, 2006-2007, for 215 days on board, 10 space walks, so this is really on top of the scale, really, with the total time EVA time of 58 hours, 18 minutes, which is kind of, I think, the record amongst NASA astronauts. So that's, yeah, it's worth an applause. So that was his NASA career, but after after he left NASA in 2012, he served as president of the Commercial Spaceflight Federation through the end of 2014, and afterwards as an independent consultant for different companies. But then in 2017, he joined Axiom Space as a director of business development, and there he's now the chief astronaut.
Kayıt, video kaydı var komple, ses de dahil.
2022, he was the commander of the Axiom 1 mission, which was actually the first Axiom mission on board the SpaceX Crew Dragon to the International Space Station, bringing 3 space flyers to the space station, and we will be having the pleasure to welcome 2 of them later today on stage as well to talk about their experience. He has now, looking a bit ahead, already been assigned as the commander of the Axiom Mission 3, so you must be already quite in training, and we are very happy that you could join us here this week. The flight is scheduled for early 2024, and of course we are eager to learn more about this flight, but also about many other things which Axiom Space is doing, and you see it already here from the picture, building for beyond space station, spacesuit, whatever is around. So please join me in welcoming on stage Michael López-Alegría.
Hello. Hello. Good morning. Dobry utro. Cristian, very kind words, probably a few too many, but I appreciate it very much. Hello everybody, it's a pleasure to be here and speak to you. A lot of very familiar faces, in fact most everybody, but I hope to give you some insight on what Axiom Space is doing as a company. Just to put things in perspective, it is one of many what we call new space companies, so I would say non-traditional, non-necessarily government contractor companies that are now in the space arena. Of course, SpaceX is probably the most famous, but there are several others, and you'll hear from my colleague Tom here in a second about Sierra Space, and of course Blue Origin is in the space, Virgin Galactic, and many others. So Axiom Space is founded in 2016 by Mike Safardini, who's a former ISS program manager at NASA for the last 10 years of his 30-year career there, and Cam Gafarian, who was the G in SGT, which was the largest engineering services contractor at the Johnson Space Center. And when Mike was getting ready to leave NASA, he and Cam sat down and asked themselves whether a commercial space station would be a viable thing at the when ISS is retired. They decided that it would be, and so Axiom Space was born. So let me talk about the company just a little bit. Mission and vision statements are mandatory. I'll let you read them if you'd like. Actually, I'll read for the translators. The mission is to improve life on Earth and foster possibilities beyond it by building and operating the world's first commercial space station. And the vision is a thriving home in space that benefits every human everywhere. Some nice imagery of the station, which we'll get to obviously in a little bit. So we basically have 3 phases of building the space station. The first phase is what we call private astronaut missions. These are missions to the ISS, and they have 2 purposes. One is to establish an operations team at Axiom that works with the operations team at NASA to develop products, to understand the communications back and forth, to understand the requirements, and to give NASA confidence in our ability to one day host their astronauts when the ISS is retired. And the second is to build a market. Obviously, the governments of the 15 nation governments of the 5 agencies of the ISS don't need to look for customers. They are their own customers. We want those agencies to be our customers, but not all of our customers. So we're out building the market in two different segments. One is private astronauts, and when that private is a little confusing because they're all private astronauts as far as NASA is concerned. But private astronauts in our parlance are people who go self-funding. And then government astronauts, which are private astronauts that are funded by their governments. And we'll talk about the mix of those that we have so far. So as Cristian said, AX-1 flew in 2022. We launched in April. Supposed to be 8 days docked at the space station, ended up being 15 days docked because the weather was not suitable for us to land. But it was a first step, obviously, a very steep learning curve for both us, NASA, and SpaceX, the three main partners. I would say it was a success, but we learned a lot from the lessons that we applied to the next mission. And I think I've got a brief video to talk about it. I don't hear anything. Stand by. We're missing the good parts. I'm going to start over and give them another chance to I'll narrate this. There's a bunch of noise, countdown followed by a bunch of noise. We had three crew. Larry Connor, whom you just saw, is an American businessman from Ohio. Eitan Stipe, who's here in the audience from Israel, and Mark Pathy, right here from Canada. Basically, our mission looked a lot like a NASA mission. In other words, our intent was to carry out scientific research. Each of them went out to their constituents, their countries, and looked for organizations that wanted to do science in space. In Eitan's case, he was associated with Elon Ramon, who was tragically killed in the Columbia accident in 2003. Following the accident, the Ramon Foundation was established, and Eitan paired with them, and they did a call for a proposal or for science experiments throughout the country, as well as a call for outreach activities, and really put together a very vast program to conduct while on orbit. Mark and Larry basically did the same thing. Larry teamed with the Mayo Clinic and the Cleveland Clinic, and Mark with the Montreal Children's Hospital, the Royal Canadian Geographical Society, and the Canadian Space Agency. So it was, we did a lot of experiments. I'd say one of the lessons we learned is that we were a bit too ambitious. We probably didn't allow enough time for the crew to get used to microgravity. We were jumping in on the science the very first day we were docked, and in retrospect, that was probably a little bit too aggressive. Luckily, we had those extension days that I mentioned, so we were able to complete everything. And most importantly, had we not had those days, I think we would have got almost all the science done, but probably not a right amount of enjoyment for the crew. And it's one thing to, I mean, these are not being paid by NASA to do experiments, right? We wanted them to enjoy the experience. So we finally got a chance to do that toward the end of the mission. And you can see some of the partners and the companies and institutions with which we collaborated for the science on on AX-1, sorry. Do we have any sense that the audio is working for the video? I have another video that's coming up. Okay, cross your fingers. So AX-2 just launched in May of this year. It was a shortened mission. It was also supposed to be 10 days, 8 days docked. Because of some ISS traffic issues, they had to reduce the mission, which they did before they flew. That combined with the fact that they had reduced expectations of the science they'd be able to achieve, but because we made a timeline that was a little bit more manageable, They also completed all their science objectives as well as a lot of outreach events. The crew was John Schaffner, who was another private astronaut, race car driver, and really a wonderful human being and philanthropist. And then 2 Saudi government astronauts. And they, of course, were not the first Saudis to fly, because our beloved Sultan is the first, but they really made a big mark, particularly Rayana, the first woman Saudi to fly in space. Here goes the next video. Are we ready?
Ready, copy. Welcome up. Today, we stand on the threshold of a remarkable journey, thanks to your unwavering spirit to explore beyond our home planet. And with that, let's get to work and get some history together.
I wish we had more words than just amazing, fantastic, awesome, all those things, because they fall short.
تم إجراء وإنجاز جميع التجارب العلمية والأبحاث الملوثة في هذه الرحلة بنجاح ولله الحمد، وإن شاء الله نسأل الله أن تعود علينا بالنتائج في المستقبل.
On behalf of the Expedition 69 crew, it's been an honor to share the ISS with the Axiom 2 crew. We're going to miss them. We wish them Godspeed tomorrow. Thank you guys for a fun week.
Very happy. Thank you for the hospitality.
For the sound. So just talk a little bit more about the science both on AX1 and AX2. I don't know the exact numbers, but I know that both missions conducted over 20 experiments, had more than that number of outreach events reaching thousands of people on the ground. Eitan's Rakia team, which was the name of the science mission, put together a really compelling document that describes the impact of that the mission had in Israel, and I'm sure that he would be happy to point a website to you, but it's really worth a read. It talks about the impact of having an astronaut from a country that doesn't routinely fly to space, what that impact is on their country. And here's the same slide with respect to the different partners that we had on AX2. And not too long ago, we signed an agreement with NASA for AX3. It was just announced about a week ago, maybe 2, who the crew will be. And in the image, as you see from your left to right, after me is Walter Villadé. He's an Italian military aviator. He's been training in Star City for many years as a cosmonaut. I think he spent something like 5 years on 3 different stints, trained in the left seat, so he's no stranger to spaceflight training. My dear friend Alper Gedizauci, who is here, will be the first Turkish citizen to fly in space, and it is Axiom's deep pleasure to execute that with him. And then Marcus Want was selected last year as an ESA reserve astronaut, and the country of Sweden, together with ESA, teamed together to have him fly an AX-3 with Axiom. So all three, Alper is also a military and civilian aviator, pretty unusual career, from F-16s to KC-135s to Turkish Airlines first officer, Turkish Airlines captain, then F-16 and KC-135 pilot again. Marcus is a test pilot. He's the chief test pilot at Saab. They're building a new model of their Gripen aircraft. He also went to the U.S. Naval Test Pilot School, as did I, and finished first in his class, as did not. He's a very talented guy. So just a couple slides of our training. Some of you will recognize the overhead crane in Building 9 in the Space Vehicle Mock-Up Facility. So here Alper and Marcus are doing some in-flight maintenance training with some tools. Here Alper is trying to resuscitate a mannequin, or at least strap them into what we call the crew member restraint system. If somebody's needs in dire medical condition, we do a lot of training on the medical side. And I want to spend a few minutes just talking about the training. So we fly in two vehicles, the ISS Crew Dragon, the SpaceX Crew Dragon to get to the ISS, and of course the ISS itself. And we need to learn to live and work in space, which includes how do you go to the bathroom, how do you make your food, how do you sleep, etc. But also, and probably more importantly, what to do in case of an emergency. And the emergencies you're probably familiar with are a fire, or depressurization, or on the ISS, an ammonia leak, which is very serious. So we spend a lot of time both at SpaceX in Hawthorne, California, and at the Johnson Space Center, training on those two vehicles. Here's a shot of us in Hangar X at the Kennedy Space Center. You can see a previously flown, or as SpaceX likes to call it, flight-proven booster in the background. And then just last week, the crew went on a trip with the National Outdoor Leadership School. We kayaked around the San Juan Islands in the Pacific Northwest. You see the crew there on the right, and I didn't mention Tuba. Is he here? Tuba Atasever is the backup crew member for Alper and is an integral part of the team. And along with the three, we had a flight surgeon, a flight ops person, and a mission manager with us. So all that is phase one of the ISS, of the Axiom station. Phase two is actually building the vehicle itself. So here you see kind of a cartoon of what it's going to look like. In January of 2020, we won a competitive award to attach our module or modules to the ISS. This is obviously a huge advantage because you don't have to fly a completely functional space station right from the beginning. While we're attached to ISS, we'll be getting electrical power and cooling capability from the Node 2 forward port, which is where we'll be docked to. And our plan is to launch 4 modules. The first two are basically identical. They're HABs, habitation modules, so AX1, AX-HAB1, and AX-HAB2. Each of them has berthing for 4 people. It has environmental control and life support for 8 people, so there's redundancy once we have the 2 modules up there. They will have some payload capabilities as well. The third module is the research and manufacturing module, and it's actually a repurposed MPLM. So some of you may be familiar with that multi-purpose logistics module. 3 of them were built by the Italian Space Agency in a bilateral agreement with NASA. One of them was turned into a permanent module, which is on the ISS and serves basically as a big closet. The other 2, well, let me back up and say the purpose of them was they were launched in the payload bay of the shuttle full of cargo. Once a shuttle docked to the ISS, the MPLM was removed from the payload bay with robotic arm attached to a berthing port. Stuff was taken out of it, trash was put in it, they put it back in the payload bay, and it came home. So it was intended to be launched and landed on the space shuttle. Anyway, we are repurposing one of those modules to be our research and manufacturing module. And then the third, which is power and thermal module, will provide those capabilities that I mentioned. We'll be borrowing from the ISS. And once that module is in place, and we want to do that sort of late because the solar array management is already very complicated on ISS, and adding another set of arrays will be even more so. But once it's in place and checked out, we can then separate and become a completely independent free-flying station. For those who've been on ISS, this is going to be a little bit different. So you know that the modules, I should say the racks in the ISS, where all the basically equipment and experiments are housed, are mounted transverse to the longitudinal axis. So basically, when you're in a module working at it, you're standing in a heads-up position and a feet-down position, perpendicular to the long axis. We decided to do it differently on the Axiom HAB modules so that we could get squeeze a little bit more volume out of it. You'll notice that we don't have an external truss with all the gear that's on the ISS, so all the big ORUs, orbital replacement units, because of the advances in IT since the design of ISS was formalized, can now be put inside, but that takes a lot of room. So we have all these things in these 8 wedges that go around the circumference. The outside diameter is the same. In fact, I'll show you some pictures of the module being built, but it's the same process that was used to build many of the modules on ISS today by the same company, López-Alegría. Anyway, this is interesting for those of us who have spent time on the ISS. You know that there is definitely a heads-up orientation with lights in the overhead and writing oriented a certain way, and we're having a lot of fun trying to understand how we want to reorient the crew to move through the modules in a Superman fashion instead of moving through. I would say most experienced flyers will go through the modules in a heads-up orientation. But this does allow us some more, as I said, volume inside. So each of the modules will have 4 crew quarters. They are nadir facing, and they have really nice windows. The interior design was done by a French designer called Philippe Starck, so it's going to be a little bit nicer than the ISS. Another nice feature is this Earth observation platform. So this is a cupola on steroids. As you can see, it's over 2 meters in height and almost that much in diameter. So you can have quite a party in there, and it'll also be nadir. You'll see that where it is in the next thing, which is a video that has no sound. But this is put together by conjunction between NASA and Axiom using the robotics analysis tools that NASA has. So each module is a self-contained spacecraft. It does its own rendezvous and station keeping to the station by itself. It has conformal arrays that you can see on the top and radiators on the bottom. It's basically a node, but very stretched out. So it's the radial ports look the same. There are 4 common berthing mechanisms around the 4 radial ports. The thing that was just removed is a docking adapter. So that docking adapter goes on one of the common berthing mechanisms and will allow other docking spacecraft like the Crew Dragon and the Cargo Dragon, and soon the Northrop Grumman Cygnus, to dock there automatically. Yes. Okay. The second module comes up later. Each of the modules has a power and data grapple fixture, a PDGF. Sorry, guys. And so you can see the arm, the station's space station robotic manipulator system, the station's arm, is being used, and it's actually walked off now onto a PDGF on the first HAB module. What you see there is the RMF has been attached, and then the Earth observation, Earth observatory will be moved and put on the nadir side of HAB2, and then you'll see the shutters are deployed, and we'll be allowed to well, ready for use. And then finally, the power and thermal module will come up last. One thing I want to point out is that the thrusters, the attitude control system on these modules uses methane, gaseous oxygen and methane. And the methane comes from the crew. So we use a CO2 scrubber that takes the carbon out from CO2, and then when we make oxygen out of water, we take the hydrogen left over from the water, mix it with the carbon to make methane, and the methane powers the thrusters. So we calculate that with a crew of 4 people, we can do all the maneuvering we need just with the products of the humans on board. So this sounds very cool, but this is real. These are pieces or images from Thales that I mentioned in Torino, which is where they're being manufactured. Once the shell is assembled for AX-HAB1, it'll be shipped to Houston. We have a facility at the Houston Spaceport, which most of you know is Ellington Field, that will accept this, and we'll do all the outfitting there. So all of the secondary structure, the avionics, will be integrated in Houston, which is interesting because Houston is a home of human spaceflight, but no human space vehicle has ever been integrated there before. And then finally, phase 3 is when we separate from the ISS. So as I mentioned, as soon as the power and thermal module is attached, we can separate. ISS right now is extended on paper through 2030. So we expect it to be deorbited in 2031. So sometime in that area, we will detach and become an independent space station. And then we hope to have, as I mentioned, NASA and other agencies as our clients, but as well as other customers, both private and government astronauts from other non-ISS partner countries. So now I want to switch to the third piece of what Axiom is doing, and that is developing a spacesuit. So we want a contract from NASA to develop the lunar suits, the suits that will be worn by the first woman and next man to walk on the moon. And we also want a subsequent award to build a lunar suit, a LEO suit, a zero-G suit to be used on ISS. I think we all know that the spacesuits in use today are sort of running on their last breath. They were not designed to be left on orbit, and so they are becoming more and more cranky as they get old. And so we need an orbital replacement as well. The two suits use a very similar architecture. I won't go through this slide in much detail, but it has a backpack system, just like the EMU does. It has all the life support. It has gloves, which are an improvement on, some of you are familiar with Phase 6 gloves, so we think that they'll be more dexterous even than the Phase 6 gloves were. Obviously, the boots are going to be different between the lunar suits and the orbital suit. And in fact, I tried to anticipate some questions you would have, so I've got some answers here. The operating pressure of the suit is variable, but it's up to 8.2 psi. So I think there was a conversation that I heard yesterday about why we want the, oh no, it was at a table, never mind. But we were thinking about having the gateway and the vehicle that goes to the lunar surface be pressurized to something less than normal atmospheric pressure. The reason for that is that when astronauts go into a spacesuit that's at lower pressure, it's like a diver coming out of the depths and the risk of decompression sickness. So you have nitrogen that needs to be purged from your blood, and a good way to do that is to spend a lot of time at high altitude, low pressure. If we can have our suit operate at a higher pressure, then we can reduce the time that we have to do any kind of pre-breathe activity in the suit. I think the Russian suit, the Orlan suit today, operates at 5.8 psi, and they have a notably shorter pre-breathe than the EMU, which operates at 4.3 psi, and obviously 8.2 psi would be even a bigger advantage. The duration, it can go over 8 hours, but interestingly, CO2 scrubbing is no longer a consumable because the CO2 scrubber is regenerative, so there is no consumable related, so it's just limited by power or water, cooling water, depending on the conditions. I mentioned that the glove is custom. It's being designed 100% in-house. It has a lot less of the very intricate stitching that the Phase 6 gloves have, so it's a lot less labor intensive. But it is being designed to be built off of a mold similar to the Phase 6 glove. We are considering putting a HUD, heads-up display, in the visor so we can have the data from your suit or pretty much anything displayed right on the visor. That's not part of the first delivery plan, but that's a forward growth item. It has lights and a video camera integrated and is compatible with NASA's handheld cameras. It has it's going to use the same tether protocol, so we're going to inherit the same tethers that are in use on the ISS with the EMU today. Same with the tools. So some of you are familiar with the mini workstation, which is attached to the front of the torso, and the tools are attached to it, so it will be compatible with that as well. But we're also under this contract developing some tools for lunar use. I mentioned the boots already. The size is probably good news to some in the room. They have a variety of sizes to fit from the 5th percentile female to the 95th percentile male. So we hope not to have to repeat some of the problems that the EMU had with the smaller members of the astronaut community. And finally, I thought maybe Luca would be here, but we have a plan to avoid getting water in your helmet, which is by separating the vent loop and the cooling loop from each other. Some of you may have seen the demo of this when it was revealed. Gosh, I think it was in May. The person in the suit, in a pressurized suit, basically bent down and picked up a coin off the floor. Now, if any of you have been in the EMU recently, you know that is not a possibility today, so it really has some amazing joint mobility. I talked about the pre-breathe protocol, but because of the pressure, we know that we can reduce that. We've teamed up with a company called GOO. Any of you who are runners know this company. They provide nutrition drinks and bars, I guess I call them, in the suit. And then, of course, due to NASA standards, we have to provide EVA rescue capability, including being able to rescue your incapacitated crewmate, either on the lunar surface or on an EVA around the ISS. So that is the end of my prepared remarks. I can take questions now, or Cristian, maybe you want to do some at the end, up to you. And I apologize for speaking too quickly.
The build-up of this Axiom station, will this be done by dedicated Axiom astronauts, or will be general activities of the ISS crew?
Well, so we plan to have a crew on board ISS when the first module arrives, and they will do the activation of the module. And then, you know, we don't anticipate that the module will be, that there will be an Axiom crew on board continuously, so the ISS crew will be trained on certain maintenance procedures and just care and feeding of the module, but we don't expect to use, other than the RMS, the grappling of the structure to attach it, we don't intend to use the ISS crew if we can help it.
And the arm will be crew operated or ground?
So there, we will not take the arm. I didn't mention this, but you know the ISS has this 1553 bus architecture, which is very robust, but also very complicated, overly complicated. We plan to use Ethernet protocol. And so the SSRMS is not viable for that. So we're procuring our own arm. We haven't decided on a vendor yet. And I don't actually know, I assume that it'll be a combination of crew and ground operations, but as we know, it'll tend toward the ground. Thanks.
Did you mention, or could you mention a date for the first physical element going on?
Sure, Q4 2026. Mario needs no microphone. But give him one anyway.
I think for the translation that might help. Anyway, Mike, on the cupola, fascinating. Can you, if you know, can you tell me a little bit about the window materials, how many vanes, pressure capabilities, etc.?
I can't say much, not because it's a secret, but because I don't know.
Okay, that's fair. That's a good answer.
But I know that we have one of the panes in a pressure vacuum test now. It's been there for 6 months or so. It's a 3-pane system as far as I know. It has a scratch pane. The windows in the crew quarters also have a scratch pane, a pressure pane, and an exterior pane. So, and I don't know what the material is, but apparently, as I recall, it's something fairly novel. It's not the same material that's used on the ISS.
It's not acrylic or fused silica or a combination? You don't know? Okay, thank you. TBD for later.
Okay.
Can you speak about the radiation protection in case of solar flares, something like that? Is there a particular place that the crew would go?
I don't think we've designed that concept of operations yet, but I will say we have a radiation team that is looking at how much shielding, how to measure the, sort of what we can take as a dose compared historically to the other, all the data that we have so far. And so it is a very big consideration because, as you know, most shielding takes a lot of weight, and weight is your enemy in this design process. So it's definitely in the trade space. I'm sure that there will be safe haven locations in there. It may be the capsule that's docked to it. That's what ISS does today, as far as I know. And so, right, where all the metal is. But we haven't gotten that far as to where on state. At least I'm not aware of that. So we have the company's now 800 or so people, and we're really divided between those 3 things that I mentioned. So there's a Space Station Development Facility, which, if those of you that are in Houston, is the old Fry's building that's now been taken over. And then probably have 400 or so engineers there. And we've got almost that many working on the suits. And then the headquarters building is apart. And if you're in one, you don't know much about the other. So I apologize that I don't know more. Mario has another question.
Not windows.
Not about the cupola?
You mentioned, separation from the ISS, and so I'm assuming ISS is not going to go away immediately after separation. There's going to be some delta time. So what is the plan for separation distance and that sort of thing?
The first step in deorbiting the ISS is to lower its altitude. So it's at 400 kilometers or so now, and we want to stay up at 400 kilometers, so we'll detach before they start that maneuver. But from the day they say go on the deorbit, it's something like a 6-month process to get there. So over that time, the orbital mechanics, as soon as they start lowering their altitude, will be out of any kind of a collision risk. But that's obviously a consideration.
Well, I had a question when I looked up in the internet. You didn't see that, but you didn't say that. But the suit is rear entry, so that's a new thing that probably everybody would like to know.
Indeed, yeah, it is rear entry. I don't see Victor. I think Victor has been in the suit. I haven't yet. I plan to get in it next month, I hope. But it is rear entry, and I've sort of seen it looks a lot like an Orlan, obviously, in that regard, because it's rear entry. What else can I say?
Yeah. Did you put a window on top too?
No, there is no window on top.
And then, can you explain if there's an easy explanation why is the boom so huge to deploy the solar arrays? Is there a specific reason for that? It just looks weird.
Why the boom is so huge?
The tower, solar arrays, the tower.
No, I can't answer that. I think because those arrays are folded up inside during launch, and so I don't really know. Part of that module, about the lower third of that module, is an airlock, so we don't have EVA capability until that module launches. Tom. Oh wait, did you have a question too? Do you mind, Tom?
Not a question, but to answer maybe two of the questions that were asked before, sort of answer about the radiation protection and the material of the observatory. Well, we were given a tour at the Fry's facility. One of the chief engineers of Axiom was telling us that it contains the material of the glass, contains a lot of hydrogen. And they were saying that in the case of a high energy event, it would be an interesting place to take shelter as well, because the high energy particles are captured efficiently by hydrogen. And it may give you an idea. I'm not a material scientist, but what the material is from that information as well. So I just wanted to add that.
Now you know why he's an astronaut.
Thank you, Mike. Suit question again. So it's a lunar suit. How do you protect all those seals, the rear entry, interface, all the glove linings and so on from the dust environment? Anything new that you can talk about since the Apollo experience?
I don't know. I can tell you that that's a big consideration that they have, and they're very worried about it, but I don't have any details. Sorry. Any more?
Actually, I can answer that question. There's a pressure garment underneath, and then there's a additional layer that gets put on outside the pressure garment that then covers all the bearings, seals, and all that type of stuff. Obviously, the concern for the rear seal and the rear entry is external to that additional dirt layer, dust layer, and so that is going to be a separate consideration. But it's about, it's pretty heavy. It adds additional probably 30% to the suit when you put that dust garment and protection garment on the outside. So that's good for it. We've been doing the additional fit checks with them. We've been doing the actual treadmill, other POGO and Argos testing, and in the NBL with the Axiom, the government reference suit. And so now in the next few weeks and months, we're now going to get, like you mentioned, I, myself, and some others, be going from the Axiom into the Axiom suit to then check its mobility and its capabilities as well. And then we do the same thing with Collins.
I want to mention, by the way, that the cover layer that you see in these images is not the final cover layer. It was designed just for the unveiling. We wouldn't make a cover layer that's black, but it just looks cool.
Майкл, добрый день, спасибо за доклад. У меня вопрос вот какой. По интерьеру модулей. Он отличается от традиционных, да, и поскольку человек все-таки эволюционировал в системе пол-потолок, не будет ли здесь психологического противоречия, особенно в длительных полетах?
Посмотрим.
Хороший ответ. Спасибо.
So the question was, this reorientation of the module to be longitudinal and not transverse is, will there be long-term psychological effects? And my answer was, we'll see. I mean, we don't know, obviously. I think we are of the opinion that that will be the new norm, and so it's not. They won't miss having this heads-up orientation because they won't know it in space. The lights are being designed to be annular instead of the top or the bottom, and so it'll be natural to have your head pointed in a certain direction, which is along the axis of the module. But I think it's a fascinating question. I know all of us have experienced this when you're at a work site and you're looking at something that could be on the ceiling or the floor or in any orientation, but when you back away from it, if it isn't on a wall, in other words, if your head isn't up, you have this momentary recaging of your gyroscope, which is fun, but interesting.
Follow-on question to Yuri's remark. Train as you fly. How do you train in such an environment without stepping on delicate instrumentation while trying to reach one of the octagons?
Yeah, so I imagine that our mock-ups are going to be vertical, so we'll have to have platforms to stand on, but that's how we get around it. Platforms to stand on. Yeah. Zero gravity simulator.
I think we don't have more questions at that point in time. Was there one more? Okay.
Thank you. The question about this from the structure perspective, what's the maximum mass of the station? And do you have any plans for station extension? What are the capabilities for attitude control and propulsion? Because you mentioned that you will use the methane, but will it be enough for 10-ton station to control the altitude and attitude? What will be the specific module for that, and will be enough for example, 50, 60, 80-ton station? Thank you.
Yeah, all good questions. I think the mass is, so the station is designed to be modular, obviously, right? And the mass is really limited by the launch vehicle. So we're looking at, I would say, 40,000 pounds-ish for each module launch package. But each of them has its own integrated propulsion system, and so the more modules you have, the more propulsion you get. And what I did mention is that the primary means of attitude control will be some kind of a momentum wheel. So the engines will be used just to desaturate the momentum wheels. Is there another question? We're looking at Falcon Heavy and Starship, and also New Glenn. So it just depends on timing. I think New Glenn will be ready. We'll see if Starship is ready. Starship obviously has no problem with the mass. For Falcon Heavy, it's pushing it, and it's the fairing size is also a bit of a driver. Okay, thank you all.
I had one last question. What's the design lifetime of the station?
I don't know, to be honest, but I'm guessing the modules are in the 30-year time frame. But since it's modular, we can just replace them as time goes on.
Well, thanks a lot. That was really great. So let's give him another round of applause. So now, as we move on, it is my great pleasure to introduce our second speaker today here, which is Thomas Marshburn, and it's my pleasure to introduce him shortly. Tom is an American physician and former NASA astronaut. He's been flight surgeon and he's a specialist for medical operations. He's a veteran of 3 space flights to the International Space Station, the first one with STS-127 in 2009. He then was flight engineer on the Expedition 3435 in 2012-2013. And he was then, once again, 176 days on board the ISS with the SpaceX Crew 3 mission. In 2021-2022, where he also took over the position of an ISS commander. He has done 5 MBAs, and That was his NASA career. After leaving NASA, he joined Sierra Space in late 2022 as Chief Medical Officer in the company's Human Spaceflight Center and Astronaut Training Academy. And it is our great pleasure to ask him to tell us about what Sierra Space is all up for. Specifically, tell us about the Dream Chaser, maybe Orbital Reef, etc., whatever you're engaged with. Please join me in a round of applause for him.
Is on. Okay, you can hear me great. Thank you. Really great to be here. It was about a year and a half ago that Mike and I were together on the space station, so it's a real pleasure to be able to join him here and talk to you about the future of commercial space, human space flight. So I've been with Sierra Space since January of this year. I am the Chief Medical Officer, so there's going to be a heavy astronaut focus to this, but there's a lot of reasons, good reasons for that anyway. Our tagline, building a platform in space to benefit life on Earth. On this slide, you see, I'm going to try to leave some space in between comments to allow for the interpreter, keeping good graces of Andy Turnage and others. But here you see the Dream Chaser spacecraft. The crewed vehicle, what you see there is a cargo vehicle, Tenacity. We are developing a crewed vehicle as well. We'll talk about those. Tenacity is still finishing up construction in Colorado. It'll be moving to the Cape and for its final testing at the Armstrong Laboratory to launch next year, either at the very end of this year or next year, as our first cargo mission to the ISS, the first of, I believe it's 6, through the CRS-2 contract. You see attached to the back of it the shooting star, which allows for both pressurized and unpressurized cargo. I'll talk about that a little more. And then you see Orbital Reef as one of our destinations. Attached to Orbital Reef is the Sierra Space component, our contribution to that space station. We call it the Life Habitat. It's the inflatable module. You may have heard in the news about the successful burst testing. It's a lot of exciting videos. You can look at it on YouTube. I did not embed any videos of this, but we've been able to get well beyond the required pressure test limit, 20% beyond that. That's required for our inflatable habitat. And we'll have a full-scale pressure test in December of this year. Significantly about our last pressure test, we have blanking plates, which would include, to be able to incorporate, allows us to incorporate windows, etc., hard components to the inflatable module. So here is Sierra Space, how we're located around the U.S. Right now, the headquarters is in Louisville, Colorado. That's where we have avionics and power as well. That's where Tenacity, the development room, is currently, and from which it will leave to go to Cape Canaveral, Florida. We'll be launching from the Cape. We intend for Tenacity, the Dream Chaser, all of our Dream Chasers to be, as we say, rocket agnostic. That is, we'll find the right rocket to put it on. Currently, our Tenacity is scheduled to launch aboard the ULA Vulcan out of the Cape, and we're expecting in 2026, or excuse me, Tenacity end of this year or next year. In Durham, North Carolina, we have electrical mechanical device factory there. Sierra Space has a long history. I'll talk about it just a little bit. A long history of supplying EMDs to satellite programs, over 65 successful missions, various satellites, including Curiosity rover, its descent to Mars, that space crane, sky crane that was used for that. The EMDs were developed by Sierra Space. In Huntsville, Alabama is where the pretty exciting pressure testing has been going on. It's always nice to be able to blow stuff up, fail quickly, and learn a lot from it. And but this was a very positive failure in that regard. I did want to bring up the bottom right-hand corner is the life habitat, the 300 cubic meter habitat. I've had a chance to go inside that. It's no longer inflated and still at the SSPF in Florida. But one of the reasons why I wanted to work for this company is when we had a chance to go inside and see how immense it is. For those who've seen Skylab mock-ups, it's about that in terms of radius, it's about that size. Not quite as long. But it's about 1/3 in one launch with one life module. We have about 1/3 the internal volume of the International Space Station. In Washington, D.C. is our headquarters, and in Madison, Wisconsin, and that's where we have our own life support system development, which we actually market out to other companies. A lot of plant habitat work that goes on there, and that's provided the plant habitats, some of them that have been used and that I've used, and others have used on the International Space Station. Not far from there is North Freedom, Wisconsin, where we have our rocket test location as well, rocket development and test. Let's see, I do want to add that at the Cape, Quatziela Barujo, many of you whom you may know, is a flight director, excuse me, flight controller, then flight director out of Mission Control. Went off to private business, and now he's heading up our flight operations there. A really robust and exciting system whereby we want to be able to launch and land right there with our Dream Chaser at the Cape, have our crews actually living and training there at the Cape, and just continue the whole operations there in one place. Let's see, did I get everything? Yeah. Mission Control, currently planned for Louisville, Colorado, certainly for our cargo missions, and still in work as to what's going to happen when we start having crewed missions, where Mission Control will happen. All right, just a quick listing. This is an incomplete list. Just to let you know, Sierra Space has been involved in the space industry for many years. Split off from Sierra Nevada Corporation. The final step in that long kind of split was, amicable split, was at the this year, actually, and our IT is now moving over, so we are completely separate from them as of, pretty much as of right now. All right, so a little bit about the Dream Chaser. It's 30 feet long on the interior component, about 6+ tons of cargo if you include the 15-foot long shooting star module that will be docked to the back of it. When it docks to the space station, as you know, it comes in, the Plus X will actually be coming out the back of the shooting star, back into it. For those, we've trained 3 crews now on the cargo vehicle. It's, all of them have commented, and I've remarked on it as well, it's long and narrow, so unlike, say, an MPLM or, say, a Dragon cargo vehicle, you go in and see this narrow pathway, but it seems to be very long from one end to the next, and the cargo carrying capacity is pretty immense. What we are excited about, just 1.5 Gs on entry, is intended to re-enter, like the shuttle, and then land right back at the Cape, currently at the shuttle landing facility, the strip there. So to be able to bring back crews, payloads, etc., with minimal impact. So any rocket with a 5-meter fairing, you need heavy lift, much like a lot of our colleagues in the commercial space industry need heavy lift, and so we are able to fold the wings in and fit in with the 5-meter fairing. We don't intend to have the folded wing component, as you see on the right-hand side, for all of these, but that's the current design of and build of our current Dream Chaser for cargo. So here are the Dream Chasers currently contracted out. DC-100, 6 tons. DC-200 is the crewed version of that. And then DC-300 is DoD. And beyond that, I actually know nothing about that other than what it looks like right there in that picture. And partly it's me being medical, and partly it's I'm sure I'm just not allowed to know. Now about the life habitat, that's been an exciting thing for the company, and one of the things that drew me to it. Expected to launch in 2026. We've built many of these already and done the pressure testing. Full scale will be in December. That's the full scale version you see on the right. That was at the Cape. As you can see, there's a lot of things you can do with this to include lunar habitats. Right now in our partnership with Orbital Reef, which is on the, with Blue Origin for Orbital Reef on the upper left-hand corner, we will be supplying those life habitats, which will include our life support, crew quarters, exercise locations, etc. What you see in the top middle there is a notional 3-floored version of this, more along the whole lines of the Space Hotel. We intend to fly these, though, as well as complete industrial manufacturing locations as well. Sierra Space is as much about, or even more so, about an industrial park in low Earth orbit as it is about a space for tourists, which we call our experiential astronauts, to live and work. And just moving right along, Orbital Labs, that was actually the first name, no longer the name, of our facilities at the Cape that we're going to be building out. We will be operating much like Marshall does currently. We intend to have institutions, whether it's Mayo Clinic universities, we currently have an agreement with UC San Diego and multiple others to bring the racks, if you will, the laboratories that they want to, where they want to do their experimentation on our destination, bring them to either Colorado, it's not quite sure where we're going to end up to do this work, Colorado or the Cape, probably both, for all the testing, but also for the final design to make sure it works in zero gravity, to make sure astronauts can operate the experiments. So we'll be providing technical design and support for those, safety and compatibility reviews, and actually train astronauts on using those racks. So, Janet Cavandi, as many of y'all know her, she's a former shuttle astronaut. She's the president of the company. She's my immediate boss. She's the head of, also the head of the Human Spaceflight Center. We're just now opening that up. I was brought on board to help open that up. We intend to do all of these things stated here. What I'm here to talk about particularly is, within the Human Spaceflight Center, which we're calling it, is we're going to be opening up a selection process for our own Sierra Space astronauts. When Tenacity lands, about that time we'll put out an application, so probably about a year from now, maybe a little less than a year from now, we'll put out a call for applications for Sierra Space astronauts. A little bit more about that later. It's really nice right now, especially for those who have flown in space before, to be a part of a company that is just now at the prime moment for us to help with the design. As Mike talked about, your internal compartments, we're asking and talking about the same things. I can't necessarily talk about what we're going to do, but all those human factors issues, how you work in zero-G, how you organize your workspace, what's it like to work at a spot and then have to move to another spot. Is your reorientation going to be a problem? And we've been able to contribute, Janet and I, Steve Lindsay as well, he retired from Sierra Space into June, have been able to contribute to those discussions. And so the teams are building out our living and working quarters based on a lot of that. We have a process called the crew review. It's for one thing that we all recall as astronauts is we would be in boards trying to capture what's going on at JSC and make an input to help the crew. And we're always having to make sure we attended the boards, otherwise decisions could be made where we weren't involved. And oftentimes it might even get to be a bit of a conflict at JSC as engineers are saying, we can't do what you want us to do. And we say, well, you have to do what we want what you do. We're suggesting if you want to be efficient and increase your chance of success. We're within the company now, and I have to say the interaction has been extremely positive. We've been able to make a direct input and have an influence. With, as you know, the caveat that says, don't ever listen to one astronaut. Because we'll have, which one, and how many of the three opinions that the two of us will provide do you want to listen to? So the Astronaut Training Academy, we have our course laid out. We have the training set. We're gathering our astronaut trainers. We want to be ready about a year from now or about 2 years from now to have our newly selected astronaut corps to begin training either at the Cape or in Colorado to begin to live and work aboard Unity and to operate the Dream Chaser and to launch on that. So that's coming up. really soon, and so we're making our final steps to doing that. We intend to select about 12 to 20. Depends on the mission cadence, depends on exactly when we start launching, of course, as to how large the astronaut corps is going to be. Of interest, particularly to all of us, I think, is that we will need to select 3 or 4 already flown individuals, so experienced astronauts, to be a part of those first missions. We always want to have at least one crew member on a Dream Chaser to be with the crew. And so those first ones before our own career astronauts will be there. One of them will be an experienced astronaut who has already flown in space, whether from NASA or another agency. We'll find out once we get the applications in. There's 3 kinds of astronauts we're looking for. That is our Sierra Space professionals. That's the one I just mentioned. Those who, much like NASA astronauts for NASA, will work for Sierra Space and train on all systems, be able to take care of the crew as well as accomplish the mission. Specialist astronauts will be brought in much like payload specialists. They will self-select. My job as the medical officer will be to make sure they can get on board. And if there are medical issues, we'll identify the risk. We'll come up with a plan to allow that individual to fly as long as it's safe for the whole crew and for the mission. And then finally, along the same lines, the experiential astronauts. We want, at a very base, they're going to need to practice, as Mike mentioned, you need to know your emergency procedures. You need to be able to interact with the crew and not either put yourself or the crew at risk. That'll be the base training. Beyond that, we'll have some very highly recommended work, particularly if they intend to carry out their own experiment campaign. So we will have an astronaut office. Right now, Janet is the chief astronaut of the Office of No Astronauts, other than her. Very quickly, we'll intend to have one of our experienced astronauts that we hire will become the chief of the astronaut office. The crew medical office, I'll be heading that up. Our intent is, unlike Johnson Space Center, where doctors historically came from the research world, we feel like there's always been an operational problem with that a little bit, so we're going to have our doctors embedded in-flight operations. Have an office with the astronauts, obviously, separate places for evaluation, etc. For our career astronauts, from a medical standpoint, selection will be very similar. I'd like to think that we'll be able to take lessons learned, though, and be able to say, operationally, you are a very desired candidate. So this one medical issue we can definitely handle, we can take care of, we can minimize the risk and bring you on as a career astronaut. That is our intent. The Astronaut Training Academy, I already talked about, and then a Human Factors Office. Proposed currently, we have a robust, small Human Factors team within Sierra Space now, but much like the engineers that were inside, embedded in the NASA astronaut office, this will be our our colleagues, our folks who really understand spaceflight. They've been around us, they know what it's like, and they can speak for us, or at least bring, spread out to the boards and bring any controversial topics to us as they come up. That's very much in work right now. We're currently working and working really well right now. A little bit more detail on what we want to train. We want to take the best. We think the NASA training, while we probably all felt like we didn't need quite as much training in all areas as they've given us, we want to take lessons learned from that, make it as efficient as possible. We certainly will have our classroom work. We're going to have our experiential work, our analog environment work. We're talking with even private vendors who are developing a NEMO-like underwater habitat. I believe that's one of the best analogs for spaceflight. So we'll be involving that, using that. Zero-G flights for at least an intro to the weightlessness experience. We're going to have a abort and bail out training, much like shuttle did. So we'll have our launch and entry suits. We're going to be parachute landing falls in the water. I don't think I can mention who it is, but we are about to sign a contract with an outside group that's going to be helping us with this training and supporting us in flight, particularly on the offshore work as we practice our emergencies for bailout. And let's see, certainly for safety, we want to be very clear. I think it's incumbent on us when we bring on astronauts in there. We'll probably have a final selection of maybe not 120, but something like 50 to 120. It'll do up the full physical with, but it'll be very clear to them all of the dangers they can expect from space flight before they actually sign on the dotted line if they were selected. And we'll be repeating that throughout. Here's the mortality rate, morbidity rate, here's what you can expect, particularly space adaptation, the effects on your body. If you end up working for Sierra Space and have multiple 6-month missions, what's likely to happen to your bones? What we're going to be doing with taking care of your exercise, your nutrition, etc., to make sure that we minimize the chance of any long-term effects from long-duration space flight. I think NASA's actually done a very good job with a lot of that, and we'll be continuing that as well, and including a really robust. We've been having planned a very robust radiation monitoring program. We obviously have our astronauts will be career astronauts will be radiation workers, and they need to know that as well. So just a little bit more. I've already spoken about this regarding the crew review process. That is just how we intend to incorporate our astronaut corps into the rest of the Sierra Space Company. Right now we're about 2,000 employees, so we'll have a fairly high percentage of astronauts as part of the company once we get going. So we'll be able to put them out and inculcate them into the rest of the team. This crew review process is intended to take that hallway conversation where someone asks an astronaut an opinion, turn that into an easy way to cache what they've said so it's searchable, so we don't repeat those questions over and over again, so other astronauts can take a look at that and say, yeah, I agree with that, and try to maximize the crew opinion, whatever it ends up being, for the rest of the design and the rest of the team. I'm about done with the slides here. Yeah, this might be my last slide. We, or in particular, my job is also to have a robust around the world, but particularly at the Cape, medical response. As a dream chaser, it can come down and land on a runway. It can land on other runways that the shuttle could not, shorter runways, so it can theoretically come down about anywhere. So we need a medical response that can go out if we had an emergency deorbit from space and ended up coming down in pretty much anywhere in the world within the latitudes. But in particular, be on standby for launch and for landing as well, to include vehicle extraction techniques, much like we had with the shuttle world. And that might be the end of my slide presentation. Some more words on the labs. I've already spoken to each of those bullet points there. And let's see. Just in general words, as I mentioned, we intend to have a manufacturing capability in low Earth orbit. It'll come out in the news this morning in the U.S. I think it's a CBS report that so I believe I'm allowed to talk about it. We just finished our Series B. Combination of Series A and Series B has ended up becoming the largest series raise for an aerospace private aerospace company in history. Around $300 million on the Series B, and so that'll be announced and at least come out in the news in the U.S. morning here later today. So a lot of confidence in the company and what we're doing. We're pretty excited about moving ahead. We have Tenacity getting ready to launch. We have our life habitats, our inflatable modules that are going to be launching in 2026, and then our crewed vehicle, Dream Chaser 200, soon after that to bring crews to that station. There's a lot of technical detail that I could talk about the life habitat. Some either I don't know or I can't talk about, but I'm going to let most of the rest of the presentation just be if y'all have any questions about it.
Hey Tom, thank you. Hey, you mentioned
mentioned ensuring that your astronauts would truly understand the risks to which they're exposed. Now, you know, sort of as a government astronaut, we had access through, you know, government employee associations and things to life insurance. You know, and a lot of private companies would not insure people who are, you know, who are astronauts and test pilots and things like that. So, you know, is Sierra Space going to facilitate your crew members having access to life insurance, for example?
Certainly facilitate. I don't think Sierra Space is going to be a life insurance company, but yeah, certainly facilitate. And even though we had access to that, I know there were astronauts or are astronauts that still don't have life insurance. You know, it's up to them to get it. But certainly that'll be a part of the discussion when we, even before they hire on as astronauts, say this is what we expect from you, because it's, you know, it's still a dangerous business. It's not a roller coaster ride.
Yeah, could you talk about the abort modes for the Dream Chaser? How do you get off the pad? How do you get off in an early stage of ascent with the lifting body?
Right, the Dream Chaser 200, you saw in the picture there, there's various methods. I don't know actually what that's going to be to abort off the pad. Certainly we're going to be needed that for a human-rated vehicle. But we are going to have abort modes that we follow. We're building that right now. A lot of that's through working with ULA to understand, you know, speeds, altitudes, etc. And so that's being developed right now, what those modes would be. But it'll be similar to shuttle. Your 25,000 foot is a good time to get out. And exactly the method we'll use to get out through the rear is going to be, you know, we're working on those operations right now. But the bailout. And bailout, yeah, to bail out, right, to bail out. And so, yeah, getting into the our launch and entry suits, having a parachute, and getting out much like we did in the shuttle world. The benefit is that we can get out the rear as opposed to having to jump out the side and have the risk of hitting the wing when we jump out. So that's why we have the long extension pole coming out the side of the shuttle. So out the rear, parachute down into the water, search and rescue. Mark?
I think we
Oh, sorry.
At least I got the mic.
Thank you.
So you're going to create your own astronaut corps.
Right.
What about other nationalities than Americans?
Yeah, that's in discussion right now, and I know leadership is talking about that. Certainly an expectation that would be possible, but I don't know. I don't understand the legality, etc. So certainly that is being brought up right now. Right. Bringing in whoever has spaceflight experience, we would consider, at least certainly from a crew selection standpoint, consider using them.
Yeah, because as a foreigner astronaut embedded into NASA there, at least at the beginning there were no differences between us or me and the American astronaut. But then later on, this became more and more complicated at the point where we had, you know, meetings and we had to leave because we were not Americans.
Right. One thing I will add, though, is we want to have our experienced astronaut corps, and therefore, once we fly with those who've flown before, we will have our own veteran astronaut corps, and then continue to fly with them. So this will be a relatively short period of time, but certainly if there's another agency, you know, they work out all the issues, then the seat's open to everyone, really.
Tom, so my question was partly answered by the answer to that question. I'm sure like many of us in the room, when you speak to youth, one of the most common questions is, how do I become an astronaut? Other than the veteran astronaut corps, will there be a selection process for new astronauts, and if so, can you describe that process?
Right, so it's going to be a lot like Johnson Space Center, and yes, out of the 12 to 20 we're going to be selecting, only probably about 4 of those will be veterans. Because once they have had their flights, we'll be able to take our newly experienced astronauts, Sierra Space astronauts, and fly them. I suspect, therefore, that subtract 4 from the total that we hire and that we select, and they will be civilian. They might be from inside, we're advertising inside the company, that they'll be able to apply, but certainly outside as well. So we anticipate a big rush of applications. We're developing our boards and our folks to start reviewing those and then start paring down so that in about 2 years from now we'll have the core. But they'll be coming from all comers. Does that answer your question?
Well, what type of people would qualify for, other than Sierra employees, what type of people would qualify?
Yeah, we'll be looking for much like NASA does. Interestingly, we much like our long duration selectees are those we brought into the NASA astronaut corps. I wouldn't say there's going to be a less emphasis on test pilot background, particularly test pilots, but pilots are so great, you know, it's in their DNA about how to operate a spacecraft, so that's very useful. But it'll be very similar. Scientists, it'll be STEM, STEM fields, military pilots, similar to what the Justice Space selects from.
Tom, can I have an add-on question to that?
Definitely.
Why wouldn't you, if you're talking about 12 people, why wouldn't Sierra, as a company, find people that have this background that you want, fills those criteria of pilots and scientists and really super advanced humans, but also have them being paying customers, so that, I mean, it must exist, like those.
So what I'm talking about is for the career astronauts for the company. So
oh, because they're going to be staying on for years and years and years. That's why.
That's it. Yeah. So that is their first mission. Let's say we have 4. We'll be able to fly 2 to 6 on each mission, and anything beyond the 2, which would be ultimately one experienced astronaut. The first missions will have the veteran from outside Sierra Space, the Sierra Space career astronaut who's developing experience. So that leaves up to 4 folks who certainly could be coming in either as what we call our experiential astronauts or as our formerly payload specialists, but our specialist astronauts. So, and those would be paid seats, right? I'll let y'all determine the order here. Yeah. Yes, sir.
Thank you for the presentation. What was the motive behind the design of a commercial runway landing space plane?
I think it was, what was the motivation behind the design, say, of the Dream Chaser? It's a legacy design. It's from it's come from both U.S. and Russian development, and many believe in that lifting body design as an efficient way to get humans up and back to the ground. And we all kind of love the image of the thought of still continuing to fly something similar to the space shuttle. Ultimately, very reusable tiles similar to the space shuttle. Soft landing, so you can either a medical emergency or hopefully much more often payloads, crystals, stem cells, organoids, etc. Very delicate 3D printed human organs. All those things that we could do up on the space station and bringing them back delicately to the ground and being able to put them pretty much anywhere you want. Some of the vision of the company is to someday be able to say these individuals have this cancer, they're being treated at this facility. We can fly their individual particular stem cells, bring them up to space in microgravity, in weightlessness, developing much more rapidly, not only grow the cancer that they have, then find out and test out amongst, say, 1,000 drugs, what's going to work for them, and have a human in a, what do they call it, a human in a chip, say, see how that drug's going to be metabolized in their bodies, and then bring that drug right back to the location where they are and treat them. So that's just one avenue that this could continue on.
A last following question based on your answer. So does it have a backup landing capability in case of a contingency or an emergency case?
Most any runway.
Any landing capability into the ocean?
Into the ocean right now, we're exploring that possibility, but right now we're intending on a runway landing. Okay.
I would suggest to have one last question over there, and then we need to just wrap it up in order to proceed with our panel.
Coming back to landing capability, I love lifting bodies. However, they have a limited cross-range capability. So, which means
yes, in principle you can land on any strip. However, not on every orbit route.
Right.
So let's assume you have an emergency situation on the orbital reef. So what can you do? How big is your cross-range capability?
Yeah, those details I just don't know. Yeah.
Okay. So you have to wait for a long time until you can land on a strip?
I suspect, I'm not an expert in this area, but you plan the undocking to when you can, within one orbit, get back. How long you'd have to wait before you undock? I've not heard they would have to be any more than, say, 24 hours while you're, whatever you're having to do to your station, much like on ISS, decommission it, package it up, whatever, get the crew in there and come down. I have not heard that that process would be any less than 24 hours.
Mm-hmm.
But again, I haven't talked to all the GNC specialists about that.
I realized that you, but also Axiom Space, carefully avoid the term tourism. Okay, you just say experimental, astronaut, whatever. You know? What is the reason for it?
So Mike could answer from his standpoint. I don't know if that's true. It's sure. So tourist people that want to look at the Earth from space, do their music video, whatever, Beyonce in space, sure, we could do that. But I think in our company we avoided a little bit because of the seriousness of what they're doing, and it'll be very clear to them what it takes to go there. And not only the infrastructure that's going to put them there, but again, as I mentioned, the risk that they're taking, which is all, we want to minimize that, we want to maximize their experience so they can talk about how wonderful it was. But that's why I would say, just the seriousness of the job. Even though they might be going for it.
This is not a good idea.
Yeah, it could be.
Personal view.
And what's it's a good point, and it may very well be that, hey, this is just like going to Bali, just going to the space station.
Okay, thanks.
Well, thanks a lot. We are a bit running out of time. I would suggest to give Tom another round of applause. I would like to ask you to stay on stage because we would like now to spend the last 10-15 minutes in a quick panel. I don't think we need chairs here. We will just ask you to stand for this 10-15 minutes. I'll ask Mike to come back as well. And we would like to invite now on the stage those who have done these commercial space flights, it's my great, and those who will be doing it in the very near future. So it is my great pleasure now to call up on stage Eitan Stibe and Mark Badi. Eitan is an Israeli former fighter pilot, businessman and commercial astronaut, and Mark Badi is a Canadian businessman, philanthropist, commercial astronaut, CEO of Maverick, a privately owned Canadian investment company, and he's also chairman of Stingray Group, if I'm right. And both of them have flown together with Michael on the Axiom 1 mission in November 2020. I would also like to call up our two upcoming space flyers here from Turkey. I'd like to ask Alpa Gezerafci, if I'm right, my pronunciation is correct, and Tuva Ataseva to come up, if that is fine. We wanted to talk here on this panel a bit about the values and challenges of commercial astronauts, private astronauts, whatever you would call that, for astronautics in general, but specifically also what did the flights you, Mark, you've done bring for you personally, but also for your country, for the general community, and what would be your advice to the upcoming space flyers they might want to consider? Maybe we start with that.
Thank you very much for the question. So first of all, we were lucky to fly with these two guys. I mean, Mike and Tom are very experienced and gave us a lot of comfort on our way. But the biggest challenge for us was to plan, the planning, the preparation. Because one thing is the dream, I want to fly to space, wonderful. And then you start, the mission starts unfolding what that requires 5 or 6 months of training, requires being in Houston, being in Hawthorne, in Europe, and so forth. All the regular astronaut training. But what are we going to do there? I have no space agency who is going to fill up those 10 days. Eventually it was 17 days in space. What am I going to do there? So that was the biggest challenge we had. We actually created a private space agency that defined its objectives and built the mission. So we had to define the objectives. One of the main ones was Space for All, which is a theme that and to not only bring along the space enthusiasts, but everyone. And everyone means children, means philosophers, poets, everyone. So we created a private space agency with committees that did science, and you all the time speak about science, but space can offer much more than science. It's an imagination. I believe that if we would have philosophers on board, space would offer humanity much more. So that's what we did. I took along scripts from philosophers, from authors, from children. We did competition. I'll just give an example. We made a competition for high school kids to write poems about perspective. And then there were professors that selected which poem I would read from space in our language, which you can do later in Turkish. And that inspired the whole country. That's just one example that I can go on for hours. Thank you.
Thanks a lot. Mark, as a businessman, how did you see that?
Yeah, I think there were a few challenges. One, obviously, the financial cost of a self-pay mission is still very high. In fact, it's gone up. So I think that's a challenge for anyone considering that. Then there were a few others. Unlike, say, a career astronaut, I had a life, another life before that, and to prepare oneself to basically abandon that for a period of, for me, between the training, quarantine, and the flight itself was 8.5 months or so, was a challenge for me in terms of managing my business and my company. One that obviously I felt comfortable with and overcame. And then there's part of abandoning that life also is the absence from family and everything like that. In terms of assembling a legitimate payload, that I found less of a challenge. In my case, I reached out to the Canadian Space Agency and to the Montreal Children's Hospital, which has a research institute. I'm on the board of that foundation, and was very quickly introduced to Dave Williams, a retired Canadian astronaut, who graciously agreed to be my science lead on this mission, and we put together a full payload in coordination with the CSA, who ultimately put us in touch with a number of Canadian universities and other research institutions, and put together quite a meaningful payload. I think one of the concerns that I had that changed over the course of our training and flight. When we signed up for this, it was right at the beginning. It was right at the time that there was this Branson Bezos kind of showdown to see who would have the first suborbital flight, and there was a significant amount of negative publicity around that for them, and so that was very much a concern for me and my family. We generally keep a pretty low profile in Canada, and the idea that particularly participating in this somewhat historic first mission would raise that profile and possibly in a negative way. But I would say that one of the things that was very gratifying for us is that while I can't say there was zero negative publicity, there was very, very little, and in fact we were very happily surprised to find that in our community and elsewhere that there were a surprising number of people who knew about it, but were also and followed it, but were excited and in many cases inspired by it. So I can't say, I don't think my national experience in terms of the country and government getting behind it was the same as ATAN's in Israel, but certainly from a community perspective, it was seen very positively and was considered inspirational. So.
Well, thank you very much for sharing this insight. I'd like to give it now to Alp, because I mean, you're a bit different category. You're a so-called government astronaut, but still, I think you're also looking forward to leaving a legacy of your flight. So what are your aspirations in that?
Well, to start with, I have to mention that these are the initial heroes who opened the path for the private commercial astronaut missions, and they faced up with the initial difficulties that could be experienced on this path. I have to say that, first of all, we are really so lucky to be flying, to be executing this mission with one of NASA's most experienced former astronauts, Michael López-Alegría. We are so happy and privileged to have him as our commander. Ever since, from the first day of our meeting with him, he has been sharing his great wisdom, experience, as well as all the experiences that he has collected and gained up through the NASA missions as well as Axiom missions. So we are so lucky in that manner. On the other hand, these two gentlemen here, together with Larry Connor, they have been the pioneers of initial private astronauts. So I don't know the magic, how Axiom managed that, but I have to tell, even though they are a professional company, they are creating such a great family environment and harmony from the first moment on. And even though we had the chance to be able to meet Mark and Ethan here, they immediately started to share all their experience with us in a family environment. So we are so lucky in that manner, and I don't see any kind of difficulty ahead of us that we might be facing with and we could be having a difficult to deal with.
Thank you. Tuba.
Well, aspirationally, I think we have been talking about it for the last 24 hours, and the overall training with Axiom has been extremely fruitful, and we're so grateful for the opportunity to work with Axiom in this training program. One of the challenges that I would like to touch on that we have been facing over the last couple of months since the training has started at NASA is we briefly talked about in the previous presentations today, but having access to some of the ops products, the Optimus and the IPV, having access to those things before the mission, and at least during the quarantine period. Since our mission is so short, it is a sprint. In 14 days, we have to achieve a lot, and having early access to those products and getting us familiar with the procedures and whatnot in our timeline would be extremely helpful. So that is one of the challenges that we have been facing, and other than that, it has been a joyous experience. I mean, I feel like a kid in a candy store, so it's just great. Thank you.
We are running a bit out of time, so I would suggest not to have questions now. I think you will have the opportunity during coffee break and other breaks to talk to the gentlemen. But I would like to ask our two representatives of our commercial operators to give a final word on how are you going to manage these kind of different types of astronauts, really private people, government astronauts, and bring them all together.
Ask Mike if I could say a few words first. I was the commander on ISS at the time when these gentlemen arrived, and with Larry. There were a lot of lessons learned. I mean, here are guests coming up to the station. They didn't grow up in the astronaut corps, didn't have the corps culture, et cetera, et cetera. But you know, any shuttle that ever arrived at the space station with astronauts that have been in the corps, been training, and have their operational backgrounds, they're all learning how to operate in space. It's complex, it's difficult, just learning how to set up your workstation, etc. When we found out the quality of the payloads they were bringing up, the entire crew was completely on board. We wanted their mission to be 100% successful. There were lessons learned from them, certainly for us, but I would say it was 100% successful. I agree with Mike, and that we probably had about the best guests coming up on board that we could, because they were very serious about their work. They wanted to do the right thing. They wanted to support both the station and get their job done. And so it was a fantastic experience from the start. Lessons learned, yeah, but we'll always have those.
Thanks, Tom. I think, so I said it yesterday in my speech, but you know, we are at an inflection point in human spaceflight, and we need to be cognizant of how we got here, and a lot of that is on the shoulders of people in this room. But we are transitioning to a different world, and it's a no less dignified or meritorious world. I don't know who asked the question about tourism, but these folks are not tourists by any stretch of the imagination. They worked hard, they trained just like a professional astronaut. They were admittedly not as prepared because it wasn't years that they spent, but rather months. But this is a template that I think we can all go forward with. At least for now, all the orbital astronauts that have flown have been astronauts in the same vein, cut from the same cloth as the people in this room before them, meaning that they're doing meaningful work, whether it's research or outreach or combinations. And they've all brought various experiences and talents to the table. Some of them are military aviators, some of them are businessmen, but they all have something to add to this. And we're just expanding the population that is able to experience what we've all experienced. And the more of them that there are, the better we can make the world, because that sense of the overview effect and all the other aspects spreads to more and more people. So it's a positive step. I know that it's difficult for some people who have grown up as astronauts, and like I was a Stele test pilot and didn't embrace this idea in the beginning. I think it's time for us to embrace it, to acknowledge that this is a viable, important part of human spaceflight.
Thank you very much.
After the tourist question, you start to think in your mind, why exactly do we say that? I would say there's a subconscious addendum to tourist, which is just a tourist. Certainly these gentlemen were not just tourists, and typically those who take the chance go through the training. They're all pioneers, and when they arrive, even if they didn't arrive with that intent, they realize how important and how wonderful this is, and they come back wanting to establish a legacy. And there are programs that let us help you, in Sierra Space will have a program, let us help you tell your story to the world, follow up on the research, follow up on outreach, etc. Therefore, maybe someday we will have thousands, I'm sure we will have thousands of unnamed individuals who are going up for fun, and we'll call them tourists. But I don't consider any of these gentlemen or anybody in the near future, particularly as we get people who are at various age ranges with various diseases, etc., that we're allowing to fly. They're pioneers, and so maybe tourist is an okay word, but that's why I don't like it too much.
Well, thank you very much. Thanks for the great presentations, for all the insights you have given us. Thank you for the great questions, for being here, and I'm very humbled, honored to have the opportunity to moderate this session. Thank you very much. Let's give them a round of applause.
Cristian, I think we continue then in Baku. ASE.
Ses 1 2 3 4 5. Ses 1 2 3 4 5. Benden gidiyor.
Tomorrow. Yes, are you excited for the community day? Are you excited for the community day?
afternoon program. My name is Matthias. I'm one of the first-time flyers and already like thrown into the cold water here to run one of the sessions. We swapped a little bit the order and we added one more presentation, so we will have 5 talks in the next 2 hours. The last talk is my ESA talk, my ESA update that originally was foreseen on Thursday. It's now this afternoon. But we will keep in time the next 2 hours. There's a very interesting program, especially also looking forward to our Chinese guests. 我们很高兴看你在这儿. And so we'll learn about the updates on the Chinese space station. It was foreseen the first talk, but now it's due to the late arrival, we put it on place number 4. All right, Danny, I will hand over to you. So you have like 2 space flights on the space shuttle and I believe 4 spacewalks, and now, yeah, you lost counting. Was it 5? No, so, yeah. And now you're working, I understand, like on spacesuits, and you will give us a short introduction on the history, and then hopefully a longer overview on your work currently developing the next Collins spacesuit now, which is also one of the 2 competitors for the NASA spacesuit. I hand over the mic to you.
Oh, yes, thank you. Okay, so I appreciate that. Yeah, so for those who don't know me, my name is Danny Olivas. I'm currently a director for engineering and mission systems at Collins Aerospace, and I am a chief test astronaut as part of their next generation spacesuit program. So today, a lot of us in this audience are familiar with the suits that we trained with during our era, but many who are here don't have that as a background. So what I thought I would do in preparation for a talk that we're going to have on Thursday is kind of go back to where we were. Typically we think of human spaceflight as those crew members that are inside the pressurized compartments, as we've seen from today's talks and discussions that we've had yesterday, but obviously going out and exploring either the slow down for the translation. Thank you very much, Randall. But so, exploring the moon, obviously, is something that can't be done from inside, not as effectively as it can be done from outside. And then also orbital destinations. We're talking about commercial LEO destinations such as Orbital Reef, Axiom Space Station, and any of the other ones that are coming up, including ISS. Can and often do require the ability to do EVA. And so we're going to briefly go through the history of how we got here. It's always good to start there. So first off, what does it take to keep a human being alive in space? Again, many of us are familiar with this, so I apologize for going backwards. But the internal pressure of the suit has to be one in which is stable. It's also one that actually interfaces with a number of these elements, these blocks that you see here. The lower the pressure inside the suit, the greater the flexibility, because it's the lack of resistance of moving against the suit. However, there's a trade-off that occurs, because as we go to lower pressures, we run the risk of potentially having decompression sickness, or typically the DCS symptoms that can occur as we go into vacuum. And there's an absolute minimum that we can go down as far as pressures within the suit if we use 100% oxygen environment. For the sake of the work that's been done in space, O2 being an O2-rich environment is the most efficient and effective way to provide the humans what they need in order to be able to survive. Often forgot in the gas makeup within the suit is that of carbon dioxide. Carbon dioxide production is something that we do naturally because of convection here on the Earth. We don't necessarily have to be too concerned about ever having CO2 symptoms, provided we have pretty good ventilation around our face. In the spacesuit, because it is a confined environment, basically a little spaceship that the astronauts live in, CO2 management is an important thing, and we'll talk a little bit about that in Thursday's brief, but being able to manage CO2 gives us the ability to prevent things such as hypercapnia, or even potential tachycardia, which can be a heart ailment that could potentially paralyze and ultimately kill the astronauts. So that's something we want to look at. And then along the way, regulating the body temperature. We don't, again, think about it here on Earth, but being able to regulate the temperature inside the suit is extremely important. And we currently do that essentially through the heat exchanger of the control environment, the LCVG control environment, inside the control environment, inside the suit. And then at the end of the day, we have to be able to get all that information out. It's not just about the suits talking to each other, but also the suits talking to the ship, and potentially the suits talking to the ground. So these are all very common things that you'll see in all spacesuits. So let's kind of, where we started here, and I'll start the clock here during the Apollo era. In 1962, a company that we're all very familiar with called Hamilton Standard received a contract as a prime contractor working with ILC Dover to create the very first spacesuits for space exploration on the moon. Our first suits saw its use, I believe, in actually the very first flight, Apollo 7, and as Rusty will attest to it, he did the very first DTO on the Bliss, right? So the primary life support system, which basically allows the crew members to go outside of the spacecraft, not under an umbilical. And so these two components were vital for us to be able to complete our lunar missions here. The Collins, and I say Collins, let me just briefly state that for those of us who are familiar with Hamilton Standard was purchased by Hamilton Sundstrand, which was ultimately purchased by United Technology Corporation, which was by Rockwell and Rockwell Collins, and then ultimately it's Collins Aerospace, and now just in 2013 we're purchased by Raytheon Technologies. So a lot of company names, but it's the same people who are building the suit. So that's why I look at this as a continuous history of spacesuit development. And you can see here the very significant accomplishments on the moon, a total of 160 hours outside the spacecraft, a pretty remarkable feat, and learned a lot while we were there. So let's talk about the basics of the suit itself. And what you see here represented are two configurations of the exact same suit. This is the A7L, the Apollo 7L suit. Why 7? Well, the number of generations it took to actually come up to this final configuration. Hamilton Standard was the prime, as well as created all the life support systems, so everything in the primary life support system. ILC Dover was responsible for the pressure garment, so when we think about pressure garment, think about the clothes that you wear. The primary life support system is what keeps you alive when you're doing your spacewalk. And you see the functionality here is as an IVA suit, so basically a launch and entry suit. The astronauts came home with these, as well as the extravehicular activity and terrestrial activity suits. So we had suits that actually performed in orbit as well as on the lunar surface. Different from some of us who trained in the shuttle years, the Apollo suits were operated at a 3.7 psi. This approached near the metabolic limit of oxygen that we needed to keep ourselves alive. About 6,000 feet is really kind of where you start to see changes in the ability of the bodies to uptake oxygen. And the one thing I'd like to point out here is if you look at the weight of the suit itself. So the suit, somewhere on the order, when you do a spacewalk, of about 35 kilograms. But yet by the time you actually put all the life support system on top of it, the mass of the suit increases pretty dramatically. So needless to say that the backpack is a pretty heavy beast, and obviously is something that really needs to be thought about. Now, if you look at the primary life support system capability at the time, the requirement was for 7 hours. Now, we'll say that Apollo actually enjoyed multiple EVAs which were extended beyond 7 hours, and this was kind of a minimum requirement. And why was there a variation? Well, the length of the duration in the spacewalk is a function of not just how much battery you have on there, but also your consumables. You're talking about water, you're talking about oxygen, you're talking about CO2 scrubbing capability. And of course, we're all familiar with this, who've trained, is that we've got 30 minutes worth of backup life support. And you'll see that consistent through most of the suits that we have. Now, after the Apollo era, we had Skylab. Skylab changed the approach towards on-orbit EVA. And I'll point specifically here to the addition of, well, first off, the absence of the primary life support system, and you can see here in front of the crew member is this the astronaut life support assembly. Essentially, this was an umbilical assembly that attached directly into Skylab, and this attachment basically connected to the front of the PGS. Now, the pressure suit assembly. So the pressure suit assembly was actually the same one that we used in the Apollo era. So a lot of the configurations were the exact same. You had this assembly that was attached and connected to the umbilical and connected into the crew compartment. And the other thing that was noticeable about it is the secondary oxygen supply actually had to be worn on the right leg of the astronaut doing the spacewalk. You'll see, because of this loss in the primary life support system, the overall suit mass to do a spacewalk was considerably less. And the total life support system was really a function of the abilities of the vehicle to continue to supply breathable air. And again, you had that life support system that was 30 minutes that was backup supply. Quickly brief through here, Apollo-Soyuz, which happened after that in 1975, was strictly an IV garment, but it was the same general design as that landed on the moon. The pressure system was. Because it was only going to be used IV, a lot of capability didn't necessarily have to be on there, so the total mass of the suit, you can see here, is considerably lower, but had no life support system that allowed it to be able to function on its own. Had to be basically going off the internal capability of the spacecraft. Now, a lot of us are familiar with this design here. This is the extravehicular mobility unit. Depending on when you came into the program and saw this, you actually saw one or the two versions of it. The very first version of it, this was actually baseline in 1978. The very first version of it was configured, was referred to as a baseline configuration. And what I'd point out is you look at the total suit mass is about 115 kilograms. By the time you went to what many of my contemporaries experienced in the NBL or on orbit was actually the enhanced version, which had a lot of extra functionality and capability to improve from the baseline. And we'll talk a little bit about, I'm not sure if it's on today's presentation or Thursday's presentation. But you'll also see here that the requirements was to be able to sustain 8 hours of on-orbit EVA capability. Jim Voss will point out that that's not actually the capability. You can go more than that, right? Backup life support system. So the secondary oxygen supply has the capability of 30 minutes. What I will point out is that the original design of the suit was for 4.5 psi. So it's a slightly higher pressure than what we saw operating in the lunar environment. And not actually the one that we typically run. We're typically about 4.3, right, Randy? So, yeah, so 4.3 psi. But also because of the enhancements in the suit, we went from about 115 kilograms to about an additional 30 kilograms for the overall suit mass. So why the big discrepancy in the capability? Well, you have to remember that by the time we got to enhanced suit, we had other equipment on board, such as the SAFER. We also have the mini workstation, which allowed us to be able to do work on the space station. Some additional equipment, such as the helmet cameras and lights, which are not part of the original design. Yeah, so that's basically, I'm trying to watch my time here and be respectful. Okay, so what really goes into an EMU? And so this is a nice breakout, I think, of the EMU. You see that it's not just one single blivet that we take and we move around. It's actually compartmentalized and broken up into all different subsystems. At the end of the day, as we discussed earlier, this is a spacecraft for the astronauts. They have to have the ability to live and not just survive in space, but actually work efficiently in space. There's some minimum requirements: environmental protection, mobility, life support, communications, power, protection from micrometeorite orbital debris. Those are characteristics as well. The original suit that was designed had a 2-week life on that. And the reason it had a 2-week life was because the space shuttle came back to Earth in a 2-week time frame, and so all the components inside the primary life support system and the pressure garment system could be refurbished on the ground. It has since evolved into what the current requirements are, which is basically 6 years of duration on ISS. And so that has really kind of stretched the capability of a design which was originally designed in 1978. And since this happened, we've seen that there's been a lot of issues associated that have crept up that have been associated with everything from parts obsolescence to trying to extend the life and functionality of things such as the sublimator or even battery recharge. So it's presented itself with a number of challenges, which has been a bit of a stretch, and also kind of why we sit at this juncture right now, and actually why I'm here talking to you today. Where we have come from, although, is pretty remarkable. When you think about it, the Collins Aerospace team has had a pretty successful track record of performing these missions on ISS to include, and shuttle, to include 117 missions, 474 crew members. Of course, we got Jim's record right here, 8 hours and 29 minutes. Is that right, Jim? Is he here? So you guys had 8:29? Yeah. Okay, I thought that was Jim.
These guys hung around outside to break our record.
Well, so they had a record though. Okay. So as Rick said here, he kind of gets credit for here the 3-person EVA. We had a really great talk yesterday about the suit's limited capability once you start extending beyond the original operational design, which was to have 2 crew members go out and do a spacewalk. Once they got 3 people on the loop, they had to make compromises in the amount of data that actually went down to the ground because of bandwidth and things of that sort. So we obviously have a couple of firsts here in the United States. First female U.S. astronaut to go out and do an EVA. Kathy did that, and then we also had first all-female crew, which certainly speaks to the diversity that future programs are going to have to be able to embrace. Now, I'm not going to spend a lot of time talking about the details of what can be expected in the next program, but I am going to say that since around the mid-2000s or so, NASA has maintained an active program in developing new suits and new suit technology. So what you see here essentially is a progression from the mid-2000s pretty much all the way to the end of the 2010 time frame. The Mark III suit, it was one which evolved. It had a hard upper torso, and if you take a look at the lower section here, is also a hard brief area. And again, this was meant to be an exploratory type of spacesuit. The CSSS, that's the Constellation Spacesuit System. That had it was a rear entry suit, again developed by NASA, and had more of a conventional feel to what the EMU looks like, but again was meant to try to correct some of the issues that have arisen as a result of our use of the EMU. And we'll talk a little bit about some of those details later. But they will include everything from injury to the astronauts to mobility of the astronauts actually doing EVAs, and then also the ability to fit the anthropometric range of the space shuttle program. And then lastly, this is kind of the predecessor to the XEMU, which is one that was being developed by NASA and is a rear entry suit, or was a rear entry suit. And some interesting things here that I'll point out on this page is that the technologies that we were familiar with, like in the Apollo era, and now in this next generation, have actually changed. So for example, battery technology, lithium-ion technology, gives us greater life. We're less worried about things such as rechargeable memory on the batteries. Additionally, things like cooling. There are plenty of papers that are out that refer to the changes in strategies on the water cooling system inside the primary life support system. We essentially are now looking at technologies which are getting away from the sublimator technology and looking into some that are more of an evaporator type of technology. Another technology that we are looking into to help reduce consumables are the carbon dioxide scrubbing capability. rather than trying to build a box that has the capability to become saturated during an EVA, looking at technologies that allow us to be able to vent to the vacuum of space as we're working, so that you essentially never have a consumable problem with the CO2 scrubbing capability. Okay, so where are we at now? I'm just about done here, so hang in there, everybody. NASA in 2022 awarded contracts on a program called XXXIV, and that's the one that I'm part of. My colleague Mike L.A.'s group here at Axiom was awarded the lunar contract to be able to build a suit for lunar application and Artemis applications. The Collins group was picked for the development of the next generation ISS suit. Now, there's some interesting challenges actually with both suits. And again, this is one we're going to get a little bit into more in technical detail tomorrow, on Thursday. But some challenges for the ISS suit is that, whatever we build has to be built with infrastructure that currently exists on ISS, which sounds pretty easy until you realize that technology on ISS was actually built and delivered back in the 2000s. So now you have some compatibility type issues associated with that. I think both teams are trying to address things such as increased mobility, ability to be able to move around more in the suit, and then also the applicability to be able to make it more user-friendly across a wider spectrum of the population. There's also, as part of the XXXIV award, a crossover award which was given to both teams to basically take that technology and do what they call an extensibility study. So basically take your suit and try to get your suit to work in the other environment. So take an ISS suit, see what it's going to take to make it work in a lunar environment, and a lunar suit, and make it work in an ISS environment. The lunar suit has some really difficult challenges. If we currently hold to the destination of the South Pole, there's some very big extremes in temperature down there that we have to be concerned with. There's also a moving target here with regard to the compatibility of a suit that is basically chasing 2 programs, maybe as many as 4 programs, that are constantly changing the requirements, such as the human landing system, system that's actually going to take us to the moon, and then also the lunar transportation vehicle, which basically takes us and does the little, like the moon, it's similar to the moon buggy. And all those interfaces are all still in the design trade space, so this is definitely a real challenge. But NASA's been really gracious in that the way that they awarded the contract is they took the past 50 years of spacesuit technology development and essentially is allowing both Axiom and Collins Aerospace to be able to mine the data from the work that's been done at NASA to be able to be responsive to these 2 different suit designs so that we don't throw away what we've already worked on. Nobody has to start from scratch. And we can also leverage the experience within the NASA team. Let's see. And that actually puts me right at time, so I'm going to say thank you, and I don't know if I have time for any questions.
Yeah, I think we have a tight schedule, but nevertheless, I would still allow time for a few questions, if there are. I think we also have a second session that you said, on Thursday upcoming. Maybe you allow me to start with the first question, because this morning I learned on the Axiom suit that the CO2 scrubber won't be the bottleneck anymore. So are you looking into the similar technology? Will your suit also have an improvement that the CO2 scrubber can go beyond the 8 hours?
Yes, and so there's a couple of different strategies that can be worked, and I will say again, I missed being in Mike's talk here, so I don't know exactly what he said and what he didn't say, but I know what I won't say is that I can't really reveal exactly the technology that we're using or the approach that we're using, but suffice to say that I think we're in like minds on our CO2 scrubbing capability. Here's the thing, the more that we can reduce on consumables on the spacesuit, the greater extensibility our suits have in the representative environments. And so right now we're currently designing for, I think the NASA requirements are for maybe an 8-hour EVA. I think I'll have some of these requirements tomorrow. But if you think about it from a contingency perspective, especially on destinations like the moon, if you have a problem and you're far away from your lander vehicle and you have to be able to get back, having extra margin in your suit is going to be really beneficial and helpful.
Excellent, thank you. Are there any more questions? Burning questions? Or can we postpone some of the questions to Thursday? Then we would, okay, then I would invite our next speaker on stage. So Anton, are you ready? So Anton was 4-time commander of the ISS, and I had the pleasure of being part of your crew during your last commandership. You spent in a total of 700 days in space, that's correct? That's what I found on Wikipedia. You should know better. But 3 EVAs, now you're the deputy head of the cosmonaut team at GCTC, and you can say it in Russian and it's fully correct. And you have a title that almost nobody here has. He is a movie star of a movie shot in space. So, we're curious to hear about your mission.
Добрый день, коллеги. Я буду говорить по-русски. Да, это было, так сказано, поручено. Я сейчас расскажу. 2 года назад, 5 октября, состоялся старт киноэкипажа, командиром которого я был. В основном экипаже была актриса и режиссер фильмов. Роскосмос поставил задачу Центру подготовки космонавтов в очень короткий период, у нас было всего 3,5 месяца, подготовить экипаж, вначале отобрать 2 непрофессионалов, дальше необходимо было подготовить их к полету, выполнить старт безопасности, естественно. 12 дней на орбите надо было предоставить возможность снять часть фильма художественного и безопасно, конечно же, их вернуть на Землю. Поэтому задача была поставлена, так называемый вызов, и фильм так и называется «Вызов». Ну, 12 апреля 2023 года в этом году состоялся день, Международный день космонавтики, состоялась премьера фильма. Отбор начался в марте 2021 года киноэкипажем. 13 мая уже на заседании главной медицинской комиссии был предоставлен основной и дублирующий экипаж. В сентябре 2021 года, то есть через 3,5 месяца, экипаж сдал необходимые экзамены и зачеты и был готов к полету в космос. 5 октября 2021 года состоялся наш старт. К нам приехало более 20 довольно знаменитых российских актрис, молодых, но мы смогли отобрать только 3, и комиссия решила, что основной актрисой будет Юлия Пересильд и режиссер Клим Шипенко. Ну, здесь на фотографии вы видите те люди, которые приехали для нас, чтобы пройти отбор. Ну, только вот 2 актрисы и режиссер Клим Шипенко и его дублер Алексей Дудин прошли медкомиссию и были годны к полету. Отбор происходил как обычно. Мы отбираем в отряд космонавтов молодых будущих покорителей космоса, то есть был отбор, дальше было медицинское обследование, все они проходили вращение на кресле Кориолиса, психологический отбор, углубленное медицинское тестирование, пробы на велоэргометрии, пассивная постуральная проба, барокамера на 10 000 метров, центрифуга. Также после того, как были отобраны по здоровью, проходили еще видеопробы, кастинг. И все это закончилось заседанием главной медицинской комиссии, которая определила, кто будет в основном и кто в дублирующем экипаже. Основной экипаж, я был командиром, И со мной были два непрофессионала. Это режиссер Клим Шипенко и актриса Юрий Пелесин. Дублирующий экипаж это был Олег Артемьев, мой коллега, друг. Олег, подними руку. Вот, да. У него была актриса Мордовина Алена и оператор Дудин Алексей. Вот два экипажа. Вот два экипажа, основной и дублирующий. Сама программа подготовки. То есть Роскосмос имел опыт полетов непрофессионалов. Это были туристы. 8 туристов Роскосмос запустил до этого момента. У нас был опыт, но туристы проходили у нас подготовку около 9 месяцев. У нас было только всего 3,5 месяца, поэтому необходимо было поменять программу, еще больше ее уменьшить, взять только самое основное, то, что нужно будет для того, чтобы безопасно полететь в космос, выполнить свою задачу и, естественно, вернуться на Землю. Подготовка экипажа проходила тренировки на невесомости, полеты на самолет Ил-76, тренировки по приземлению спускового аппарата на водную поверхность, то есть выживание, морские выживания так называемые, тренировки на тренажере космического корабля «Союз» в составе экипажа, типовые полетные сутки, это тренировки на российском сегменте Международной космической станции в Центре подготовки космонавтов. Завершением всем этом была экзаменационная сессия и так называемый экзамен экипажа на корабле «Союз» один день и один день на российском сегменте Международной космической станции в Центре подготовки космонавтов. Ну, у нас по традиции, после сдачи экзаменов мы едем на Красную площадь, возлагаем цветы, где похоронены Гагарин, Королев, фото, пресса. Как обычно, мы за 2 недели до старта прибыли на Байконур, где проходили обсервацию в течение 2 недель. Также проходила доподготовка. Мне как командиру доводились последние эксперименты, также тренировки по ручной стыковке космического корабля. Также у нас есть традиция, это посещение музея на космодроме Байконур, домика Королева, Гагарина, просмотр фильма за сутки «Белое солнце пустыни», посадка деревьев на аллее космонавтов. Ну, мое уже было давно посажено, но ребята посадили, кто летел в первый раз, это Юлия и Клим. За 2 суток выводится ракета на старт, дальше идет ее заправка топливом. На вывоз ракеты ездили вот дублеры, обычно у нас ездят, основной экипаж не ездит на вывоз своей ракеты. И за сутки у нас была окончательная пресс-конференция на Байконуре экипажа. Также оставляются, после того, как мы покидаем нашу гостиницу, по традиции мы оставляем автографы на двери гостиницы в номерах, где мы проживали эти 2 недели. Дальше едем к ракете, и уже возле ракеты я, командир, докладываю о том, что экипаж готов к старту, и мы готовы сесть в космический корабль и стартовать. 5 октября 2021 года в 11 часов 55 минут по Москве произошел старт корабля. Мы должны были по программе, если все шло штатно, через 3 часа уже состыковаться с Международной космической станцией. Но, к сожалению, к какому-то сожалению, ко мне это к радости, то что да, отказала основная система стыковки автоматическая. Я 15 лет готовился стыковать космический корабль вручную, и предыдущие 3 полета были, все шло четко, автоматика работала безотказно, поэтому я ничего не делал. А в этот раз отказала система автоматической стыковки, и мне было поручено из Центра управления полетами, что я могу взять наконец-то управление космическим кораблем и как настоящий командир управлять кораблем и сделать стыковку. Сложность была в том, что впервые на корабле «Союз» летело сразу 2 непрофессионала. То есть обычно у меня у командира есть борт-инженер, у которого есть свой дисплей, есть свои органы управления, он отвечает за различные клапаны, он смотрит за всеми системами, а я как командир пилотирую кораблем. В этот раз мы не могли за 3,5 месяца подготовить борт-инженера, поэтому самая главная была задача двух участников космического полета — ничего не трогать, смотреть только в иллюминатор. Если что-то надо, только по моей команде они могли что-то делать. И то это только включить и выключить. И то несколько клапанов, то есть больше ничего. Поэтому мне приходилось во время стыковки двумя руками управлять кораблем и параллельно что-то нажимать, переключать. Ну, то есть то, что делает обычно борт-инженер. Но, слава богу, 15 лет тренировок не прошли зря. Мы состыковались, и наша миссия уже на станции началась успешно. Ну, это кадры наши полета. На борту нас ждали наши коллеги, то есть мы должны были поменять экипаж. Двое наших коллег, которые уже отлетали полгода, им пришлось за счет этого еще остаться на полгода. Это наши коллеги, российский космонавт Федор Дубров и американский Марк Ван де Хай. То есть они летали, получается, целый год. Чтобы нам вернуть через 12 дней актрису и режиссера, им пришлось еще на полгода задержаться на станции. Вы сейчас видите российские сегменты, российских членов экипажа. Олег Новицкий в фильме сыграл космонавта, которому стало плохо по медицине. И актриса Юрия Пересильд сыграла доктора, которой пришлось полететь вот так же срочно на станцию, сделать там операцию. Ну и мы с Петей, вот я и Петя, мы помогали делать эту операцию. Ну и Клим Шипенко это все снимал. Каждый день у нас были видеоконференции утром и вечером. На Земле в центре подготовки, в центре управления полетами была специальная комната, где были помощники у режиссера. Он отснятый материал, который мы снимали в течение дня по фильму, ночью сбрасывал, часть, как он считал, самый лучший, сбрасывал на землю. В это время профессиональные его помощники смотрели это все на большом экране, и уже утром ему давали советы, как лучше снять, чтобы лучше был свет, звук и так далее. Сложность была съемок тем, что режиссер хотел, и вы это в фильме, кто будет смотреть, увидите, чтобы это было все реально снято на станции, было все время видно иллюминатор. То есть все, что творится за иллюминатором, то есть нашу Землю, звезды и так далее. Поэтому, понимая, что каждые 45 минут у нас рассвет и закат, ему приходилось постоянно менять свет, а это оказывается очень сложно при съемках фильма. Ему надо все время было менять звук, потому что звук вентиляторов, кто был на российском сегменте, прекрасно меня понимает, как там очень шумно. Но надо было снять, услышать голос киногероев. Поэтому ему постоянно приходилось работать. То есть сложность съемок была в том, что обычно на съемках фильма, а после того, как я вернулся на Землю, часть фильма мы снимали уже профессионально на Земле, я видел, что 100 больше человек участвует в съемках фильма, кто-то за что-то отвечает, за звук, за свет, за камеру, за макияж и так далее. Он все сам делал один, поэтому это было очень сложно для него. В течение 12 дней экипаж был на борту, 10 дней мы снимали примерно по 4 часа в день, снимали кадры будущего фильма. Через 12 дней экипаж вернулся на Землю. Командиром уже был Олег Новицкий, который полгода отлетал. Вот с ним вернулись актриса и режиссер. А в мой экипаж вылез Марк Ван де Хай и Петр Дубров. И я начал продолжить свою полугодовую миссию. Приземление произошло все штатно, 17 октября в 7:30 по Москве. После полета были интервью, и вот Олег Новицкий сказал, что не стал бы называть это космической гонкой, мы выполняли свою работу. Было приятно принять участие в съемках и помочь ребятам успешно справиться с задачами по проекту «Вызов». Признаюсь честно, у меня изначально было предвзятое отношение к присутствию на МКС актрисы и режиссера, которые будут снимать кино. Но Юлия и Клим прибыли на станцию хорошо подготовленным, не создавали никаких проблем. С ними было очень комфортно. Актриса Юлия Пересид после полета в космос. Нам повезло с нашими командирами. Стартовали мы с Антоном Шкатлеровым и чувствовали себя спокойно. При возвращении на Землю не было ни одного повода для волнения. Олег Новицкий предупреждал заранее о каждом из этапов спуска. Для меня самое большое открытие — это люди, которые готовили нас к полету и работали вместе с нами на МКС. Люди — это настоящий космос. Спасибо. В заключение своего выступления я хочу 2 минуты показать трейлер, рекламу этого фильма, чтобы вы немножко поняли, о чем он. И когда у вас будет возможность его посмотреть, уверяю вас, вы не пожалеете, как профессионал.
Well, it's like in the Russian cinemas, it has already been, and we're all waiting now to have the English translation to have in Western cinemas. I'm sure there are questions on this wonderful project. Who wants to ask a question? Okay. So if there are no questions on this one, then we will straight head on to the next section. And I think there was more stuff that happened during Anton's stay on board. And then we will probably combine the questions for the next one. So now we are coming to the third part. It's the ISS Expedition 67 report. And so I welcome my dear friends in front. So it's Dennis, Sergey, and Oleg.
Nereye efendim? Sabah konmadılar. Eğer istiyorsak hızlı olmamız lazım. Yine bir ayar var. Ne olur?
Дорогие друзья, мы тоже будем по-русски говорить. Представляем вашему вниманию доклад об экспедиции 67. Ну, к сожалению, я только вчера узнал, что буду содокладчиком, поэтому я постараюсь покороче, потому что если бы я один, 20 минут бы не хватило. И после Movie Star, конечно, тяжело выступать, да, то есть, но мы зато, когда прилетели на станцию, все компьютеры были забиты фильмом о вызове. И даже места не было для экспериментов. Поэтому мы каждый вечер смотрели этот фильм. И сейчас мы понимаем, что космос — это очень тяжелая работа, но очень интересная, увлекательная. И у нас такое же было и путешествие. Работа была интересная. Ну и вы знаете уже, что самая главная задача нашей экспедиции была — это подготовка к конгрессу в Бурсе. Поэтому самая главная задача — это было отвезти флаг Турции в космос. И мы эту задачу выполнили. Так, вот, completed, да, вот. Задачу выполнили, сделали видео флага, сделали фото, да, фото флага тоже сделали. Почему российский флаг? Потому что русские люди, они очень любят Турцию, и это самое любимое место отдыха россиян — это Турция. А граждане Турции, они у нас работают, строят дома, поэтому, ну, как работяги, да, работают, они отдыхают, а мы у них отдыхаем. Вот. И живем в тех домах, которые они строят. Ну и еще одна самая главная задача: надо было сфотографировать Бурсу из космоса. Вот она, Бурса, вот он, Халид, видите, Халид вот идет, Халид, вот, потом, и все организаторы вот идут. Так, вот Эрдоган, вот здесь вот. Поэтому всех важных людей мы в нашем полете сфотографировали. Я уже 3 раза был в космосе, но вот эти 560 дней и даром не проходят, поэтому я не все помню своего космического полета. Помню только, как мы праздновали дни рождения моей дочки, которая родилась перед полетом каждый месяц по традиции российской. Помню, как мы играли на скрипке, порвали все струны, и сейчас она без струн в космосе. Помню выходы в космос, это была самая интересная работа в космосе. Помню, как Сергей работал на манипуляторе, управлял роботом и не дал ему выйти из-под контроля. То есть роботы были в руках человека и ничего не испортили. Это все очень хорошо помню, но все остальное забыл. А все остальное расскажут мои друзья и товарищи по экипажу. Денис и Сергей. И даю трубку.
Спасибо, Олег. Теперь мы с Сергеем продолжим рассказ и вкратце расскажем основные задачи нашей экспедиции и что мы там делали. Значит, наш экипаж состоял из командира Олега Артемьева, бортинженера Дениса Матвеева и Сергея Корсакова. Наш полет состоялся 18 марта и продлился почти 195 суток. У Олега это уже 3-й полет. Вот. А у меня и у Сергея это по 1-му полету. Наш экипаж примечателен тем, что впервые в истории МКС это был экипаж из 3 профессиональных космонавтов. И второй момент, который... Из России. И второй момент, который также примечателен: мы все втроем являемся выпускником одного учебного заведения, это МГТУ имени Баумана. Значит,
про эмблему скажем. Поскольку мы выпускники МГТУ имени Баумана, то в качестве эмблемы экипажа мы за основу взяли эмблему нашего вуза, буквально немного ее изменив, добавив корабль «Союз», его название, профиль Сергея Павловича Королева и наши фамилии. А профиль Королева мы добавили не просто так, не только потому, что мы очень уважаем этого человека, и он является одним из предтечей наших космических полетов, но это также выпускник нашего вуза МГТУ имени Баумана. И кроме того, наш космический корабль был, нам очень повезло, назван в честь Сергея Павловича Королева, то есть он был именной, носил имя Королева. И это был год юбилея Сергея Павловича, поэтому все сошлось очень удачно.
Во время экспедиции нам предстояло выполнить работы по полезной нагрузке, работы с кораблями. Также мы принимали старики, выполняли большое количество ВКД. У Олега было запланировано 7, у меня 6, получилось меньше. Основные работы были запланированы по инициализации европейского манипулятора Ера. Ну и также проводили фоторепортажи и поддерживали работоспособность станции. Значит, на станции, ну, как уже было сказано, старт состоялся 18 марта 2022 года. На станции нас встретил экипаж 66-й экспедиции в составе Антона Шкаплерова, Петра Дуброва, Марка Вандехая, Ражи Чари, Маттиаса, Томаса Маршбурна, Келы Бара. Значит, это Matthias. Вот. Значит, в период с 9 по 25 апреля к нам прибыла экспедиция посещения Axiom-1, в которую входили командир Майкл Элей, Хейтед Стиби, Марк Пати и Ларри Коннор. Его сейчас здесь нет. Значит, 28 апреля после стыковки со станцией прибыл экипаж Крю-4 в составе Чела Лингрена, Боба Хайнса, Саманты Кристофоретти и Джессики Уоткинс. Здесь мы их встречаем, приветствуем.
Саманту носили на руках буквально.
Да.
На станции было не тяжело.
И, значит, после расстыковки от станции корабля с экипажем Крю-3 экспедиция продолжила работу под руководством Олега. Здесь видно, как мы тяжело работаем. В составе 7 человек. Вот в основном экспедиция Союза и экипаж Крю-4, с которым мы провели большую часть времени. Во время экспедиции экипаж проводил работы с кораблями «Прогресс» и «Союз», а также с американскими кораблями «Дрэгон», «Сигнус» и «Боинг Старлайнер», который впервые прилетел и достиг МКС и смог состыковаться. На время экспедиции экипаж проводил большое количество выходов. Было выполнено 5 выходов в открытый космос, которые в основном были посвящены выполнению задач в интересах инициализации европейского манипулятора. И кроме того, был проведен выход, который назывался ВКД-ЕКО, который выполнили Олег Артемьев и Саманта Кристофоретти. И во время этого выхода были запущены 10 спутников. И вот один из этих спутников удалось сфотографировать. Также Сергей работал с манипулятором Ера как третий оператор из объема станции. Но в процессе инициализации были выявлены нештатные ситуации, связанные с работой кистевых захватов и камер. И поэтому во время выхода ВКД-ЕКО был проведен ряд работ, в том числе по замену стекол на камерах манипулятора. И после этого манипулятор был инициализирован, введен в строй и официально сертифицирован для работы.
Очень интересная на самом деле работа и довольно-таки уникальная именно для российского сегмента, потому что у нас на российском сегменте МКС не было до этого роботизированного манипулятора. Этот манипулятор, который был создан ЕКО, соответственно, с Россией запущен, то есть был для нас большой новый опыт. И было очень интересно для меня работать внутри станции, управлять этим роботом, в то время как ребята снаружи станции с ним взаимодействовали. То есть нам нужно было наладить это именно взаимодействие внутри и снаружи с целью безопасности, с целью эффективного проведения всех этих работ. Эра, конечно, первое время капризничала, не хотела как следует работать, но в итоге мы с ней совладали, обуздали и научились работать вместе, выполнять полезные функции. И уже следующая экспедиция она выполнила основные задачи, которые были на нее возложены, перенесла шлюзовой модуль с другого модуля на модуль наука и радиатор теплообменник. Также помогла экипажу в исследовании места утечки после того, как система термоохлаждения корабля была пробита.
Также и каждый нелетавший астронавт и астронавт состоит в неофициальной секретной организации, которая называется ЛУФА. Это Лига нелетавших астронавтов. И основная задача участников этой организации – это попасть на борт МКС и вычеркнуть свое имя из специального батча, таким образом покинув эту лигу. За время нашей экспедиции мы подсчитали, что свои имена вычеркнули 10 участников. Это говорит о том, что космонавты и астронавты без опыта полета выполняют полеты и летают на космическую станцию, что есть очень хороший признак. Также мы занимались наукой. В среднем выполняется порядка 46 экспериментов. Мы были задействованы в них. На нашу экспедицию пришлось, собственно, 46 экспериментов. И также появились 3 новые целевые работы. Это магнитная фабрикация, репер-калибр и 3D-печать. Это отработка аддитивных технологий. Пришел новый принтер, и Олег впервые с ним смог поработать. 21 сентября 2022 года на смену нашей экспедиции прибыл экипаж 68-й экспедиции в составе Сергея Прокопьева, Дмитрия Петелина и Фрэнка Рублио. 29 сентября, завершив программу полета, мы выполнили расстыковку и спуск. Спуск у нас выполнялся по штатной программе. И в 13 часов 57 минут мы расстыковались, и через 3,5 часа выполнили посадку в штатном районе, в районе Джисказгана. Ну и как Эйтон сегодня упоминал, на станции мы занимаемся все-таки не только наукой, но и пытаемся найти время, когда есть свободная минута для какого-то творчества. И в данном случае мы, обладая большим количеством музыкальных инструментов, пробовали их использовать, но Сергей пошел дальше и сумел на борту станции снять музыкальный клип, который мы сейчас предложим вам посмотреть.
Это была самая сложная часть клипа, чтобы листочки летели туда, куда надо. Потому что в космосе они всегда летят не туда, куда надо. Мы все втроем занимались этой работой. Спасибо.
You need to stay. I think there are many more questions coming now. It's a wonderful mission, and what I learned today is like to be a cosmonaut, you need to be either a movie star or a musical hero, or you need to spend more time outside of the space station than inside. So, yes, are there questions in the room? I think there should be questions. Yeah, okay, so we start with the first question.
Translation, sorry. Did you record anything on the station or after you came back or before?
Клип состоял из космической части и земной. Я отвечал за космическую часть, то есть в космосе я записал видео, записал вокал, звук и гитару. Нам очень повезло, что перед нами полетел Антон Шкаплеров с киноэкипажем, они оставили нам большую профессиональную кинокамеру, я ее очень активно использовал. Самая большая проблема была записать звук с гитары, потому что на станции очень много фото и видео оборудования, а вот звукозаписывающего оборудования почему-то пока нет на станции, поэтому пришлось повозиться с проводами, придумать, как это сделать. Вот, но все было снято в космосе. Все, что показано в космосе, было снято в космосе.
It's a big achievement. Wonderful job that you did. I didn't know that you play sort of well guitar. So there's also another question that maybe you wouldn't think of, but after I phrase it, you will think like, yes, that's obvious. So the MLM arrived at the station, the arrived at the station is now complete. Like that happened in 21. And obviously there are now more crew cabins in the space station, cayutas. So, and now I have a question. Which cayuta in the space station is the best? And I think everyone has an opinion on that.
Очень сложно ответить. На самом деле, единственный человек, который может ответить на этот вопрос, это сам Matthias, потому что Matthias проводил серьезные исследования на станции, и оно заключалось в том, что он попробовал спать в каждой каюте на станции.
На самом деле мы все вчетвером обычно спали в каюте Маттиаса. Она достаточно вместительная. Пока Matthias спит, мы потихонечку пробирались, и нам удавалось разместиться. Потому что действительно, то есть мне удалось сравнить каюту нового модуля MLM, где я провел большую часть экспедиции, и мы с Matthias'ом на какое-то время поменялись. Я пожил в модуле Коламбус, и мне там очень понравилось. Ну, сложно выбрать какую-то одну. Интересно менять места. Matthias об этом может рассказать больше.
So just to add some more details on that one, when I flew up to the station, we were 5 USOS, and as you all know too, there are only 4 crew quarters. So CASA was invented. It's kind of a flexible cayuta that you can just pull out, and then you have your own room. Doesn't have as good ventilation system from the inside than like all the other cayutas have, but I found it very quiet, and so that's why I was convinced the best sleep is in there. And we started the discussion, and we decided like, okay, we have to compare. And so we all checked out cayuta in the MLM and also in the service module. But let's come back again to a more serious question. Now that we have the MLM ready, and we have the airlock ready on the Russian side, and we have the ERA, what are the new capabilities that you see now for the Russian segment, scientifically, with these new modules?
Тот тот экипаж, который сейчас находится на станции в составе Сергея Прокопьева, Дмитрия Петелина и Фрэнка Рубио, завтра у них запланирована расстыковка и спуск, они за время своей экспедиции выполнили большое количество работ, в том числе по окончанию интеграции российского сегмента в состав МКС. Теперь на российском сегменте есть шлюзовая камера, есть УК-манипулятор Ера, и это открывает большие возможности, так как теперь будет возможно проводить научные исследования, в том числе по исследованию деградации материалов в космосе, помещая необходимые укладки и те интересующие материалы в шлюзовую камеру и экспонируя с помощью Еры их на внешней поверхности станции. Таким образом, не требуется выполнять выходы в открытый космос, привлекать космонавтов в качестве операторов, и это значительно расширяет возможности российского сегмента. Также был перенесен с модуля МИМ-1 на модуль МЛМ переносное рабочее место, которое интегрировано с манипулятором и которое позволяет по аналогии то, что есть на ССРМС и оператора в ИМЮ, переносить оператора посредством Еры и переносного рабочего места, что также сильно расширяет возможности ВКД, поскольку позволяет доставлять оператора в труднодоступные места, где нет поручней переходов, куда сложно дойти самому и, собственно, выполнять там работы. Поэтому, собственно, инициализация и введение в строй манипулятора, а также перенос и включение шлюзовой камеры значительно расширяет возможности российского сегмента.
Do we have other questions? Yes, Aiton.
Back to art and free time and space. So, the Saturday night movie you chose for us to see, the newcomers, was Salute 7. Salute 7 is about the space station falling apart. So was that, why did you choose that, and were you checking our courage?
Хороший вопрос, но на самом деле это не потому, что Салют-7, а потому что это фильм про космос. И так получается, что когда ты находишься на космической станции, то какой фильм еще смотреть, как не про космос и не про космические станции.
And it was the same director who also went up with them to the space station. So it's Klim also shot Salyut 7. Do we have more questions?
Not question, just comment. Могу подтвердить, как заместитель руководителя полетами вот по поводу вот этого экипажа, несмотря на то, что они очень много времени проводили в каютах, клипы разные делали, вот, они очень хорошо работали, и все задачи, которые им были поставлены, они в общем, не в общем, они все сделали, и с очень высоким качеством, и с очень хорошими результатами, поэтому вот эта их скромная такая презентация, она, может быть, пару процентов отражает той деятельности, которой они занимались на борту. Поэтому, ребят, спасибо вам.
Okay, big thank you to you, my friends. Time is running and we need to continue. So now I think we continue with our Chinese guests and Wang Yu. If you want to come down here and we can load your presentation, that would be nice. And while you load the presentation, I will welcome also Fei Junlong and Tsai Xuche. So please come on stage. Fei Junlong. 我看你在欧洲航天中心2013年，对了。So we met like 10 years ago in the European Astronaut Center when he was the head of a delegation coming to Europe and also to see if we can work together in space. Now your space program is so much advanced, you have your own space station, we are curious to learn all about this one. But before we go there, our president wants to give you a pin, the ASE membership pin. So we find that we have the opportunity to give you the pin. You have to contact us to receive the pin.
Yapamadım. Ben gideyim.
Sorry. Sei Schücher, die wurden kam. 我们也是航天员第一次在航天去了。So I would also to introduce Sai Schücher. So he's been last year to space, 182 days in space, 2 spacewalks, and he also receives the pin of Association for Space Explorers. Okay, so I would like to introduce Feichtinger Long with a few words. So he's been twice to space. He was the second Chinese astronaut in space, and also he flew last year. Came only back 3 months ago. He spent a total of, I believe, 192 days in space. You have several spacewalks, I believe 4. I'm not really sure. 4 spacewalks, and at the time we last met, you were the deputy head of the Chinese Astronaut Center. So please welcome Feichtinger Long, and we're curious to learn about your mission. And I also would like to introduce Wang Yu. He's not an astronaut, but he spent 520 days practicing for a mission to Mars. So he's one of the analog mission. Okay. And he will translate.
Thank you.
很高兴能够参加今天这样的我们航天员自己的会议。
Ladies and gentlemen, my friends, I'm so happy to be here to join this special conference for our astronauts, technonauts, cosmonauts.
我去年12月份到今年6月初刚刚回到地面。
From the last December to this June, I just finished my flight in Tiangong Space Station.
我回来以后，我的同事跟我说，今年的探索者协会在土耳其召开，问我去不去，我说要参加。
When I'm back, my colleagues asked me the 34th ASE Annual Congress is held in Turkey. They asked me if I attend. I replied, "Конечно."
Sorry. 因为我感觉到土耳其离我们北京很近，我在上面看了，非常快就飞到土耳其了。
One reason is that when I'm in the space, I saw Turkey is very close to us and between Beijing. So I think it should be very short from Beijing to Turkey by plane.
但是今天我坐了10个小时的飞机，还有4个多小时的汽车赶到了这里。
Wow, but however, 10 hours flight trip and 4 hours car trip is not very short. But I'm still very happy to be here.
除了吃午饭，我就站在这儿了。
With the exception of the lunchtime, I'm standing here and I'm so glad to see you guys.
首先感谢大会给我发了这么好的一个证章。
First of all, I'm so happy, so honored to be invited to this Congress and get this gift of this badge.
我想这是作为一名航天员的荣誉，也是在座各位我们这个协会全体探索者的荣誉。
I think this is kind of honor for all the astronauts and all the people who love our space exploration.
谢谢。
Thank you.
我们人类有一个共同的地球。这个每当夜里降临的时候，我们都会产生一种很深的情思和遐想。在我们中国，自古就有玉兔、嫦娥的传说，也有万湖飞天的经典故事。
We live in the same global village. When the night comes and the bright moonlight sheds on the ground, we could have many fanciful thoughts. In China, we have the fairy tales like the rabbit and the Chang'e, and we also have many classic stories like the flying to space.
据记载，在16世纪，土耳其人就发明了火箭。时光流转，到了20世纪，科学家们就开始研究如何将人类送上太空，去探索未知与浪漫的外太空，将远古的传说、古人的梦想变成了现实。
According to the history record, Turkey invented a rocket in the 16th century. As time goes by, at the beginning of the 20th century, scientists began to study how to send people into space, to explore the romantic, the unknown outer space, and to make the dream of human into reality.
尤里·加加林、尼尔·阿姆斯特朗一个个响亮的名字，成为探索太空的先驱，也是我们所有人心中具有里程碑意义的英雄。
Yuri Gagarin, Neil Armstrong, they are the heroes, they are the pioneers in our heart, in every one of us.
在这里向他们致敬，向全世界各国的航天员致敬，向全世界为太空探索者付出的辛勤劳碌和努力致敬。
Sincerely, I'd like to send our salute to the pioneers, the space pioneers, the astronauts, and all the hard-working scientists and engineers who dedicate to the space exploration all over the world.
浩瀚宇宙征途漫漫，中华民族对浩瀚太空也充满了好奇。今天，中华民族先对宇宙的不断探索和浪漫情怀，被脚踏实地的太空工作者们继承。
The universe is endless, and the way to explore it, the space is very long. Chinese people have many beautiful imaginations of the outer space, and we never stopped on the way to space exploration.
中国航天人用了整整30年的时间，建成了天宫空间站，在浩瀚太空有了中国的空间站。
It takes 30 years for Chinese to complete the construction of Tiankong Space Station. In the boundless universe, the space of dream in the world, now China is coming.
每一次飞行 标定飞越浩瀚太空的崭新高度。2003年10月15日，杨利伟踏上首次飞田圆梦的征程，在太空留下了中国人第一个太空探索脚步。
On October 15th, 2003, Yang Liwei set out for the first manned space mission of China and made the first footprint of Chinese in space.
从神舟5号到今年的神舟15号，以及神舟16号，还有3位同志在太空。中国航天员已经有18位同志进入太空。
During the past 25 years, 18 of my colleagues have flown to space in 11 manned spaceflight missions.
我们中国建设的太空家园，它不仅属于中国，也属于全人类。
Tiangong Space Station is constructed by Chinese, but it belongs to all the people in the world, all the people who love peace, who love to explore the space peacefully.
大家可能还记得，2005年10月，我和海参执行神舟6号时的情景。
Maybe my friends, you remembered in October 2005, I and my friend Nie Haishen carried out Shenzhou 6 space mission.
到太空第3天，我在上面做了一个前滚翻。
On the third day of my mission, I did 4 consecutively somersaults in the cabin.
没想到这个前滚翻成了中国航天员在太空的经典动作。
Although what I didn't expect is that this sound thing become a classic action for taikonnauts since then, and it was engraved into the memory of many people, especially our taikonnauts.
因为我今年在空间站也做了同样的动作，这时候我才知道，在空间站做前滚翻非常容易，所以我神舟6号做这个前滚翻的时候，确实还是比较难的，因为空间小。
I did a similar action when I did I was in Tiangong Space Station. I found comparatively it's easier because the space of Tiangong Station is huge.
今年我们飞行的时候，有一个很大的特点。
During the space stage, this year we have a specific trait.
就是我们进空间站的时候，神舟14的3名同志已经在那里等待着我们。
When we entered into the space station, 3 crew members of Shenzhou 14 were waiting for us.
这张图上可以看到，就是刘洋是神舟14。
Liu Yang is a crew member of Shenzhou 14.
我们的空间站基本构型。
The basic configuration of Chinese 天宫 Space Station.
有啊，这是我前文翻。我们空间站基本构型有核心舱、问天舱、梦天舱。
It consists of 天河 core module, 梦天 experiment module, and 问天 experiment module.
是3个飞船的停靠停泊点。
There are 2 spots berthing of manned spaceship and cargo spaceship, other visiting spacecraft.
总体构型就是呈 T 字形构型。
It is a T-shape configuration.
完整构型总质量接近100吨。
The total weight of the Tiangong space station is nearly 100 tons.
设计寿命是10年。
The designed lifespan is no less than 10 years.
在我们飞行这一次当中，我们完成了4次出舱任务。
During our 10-month flight, we have performed 4 EVAs.
完成了14项舱位作业。
And finished 14 items of EVA tasks.
我们也有专门的睡眠区。
We have our personal space for very good sleep, the sleeping quarters.
锻炼区，还有工作区。
And working quarters and exercise quarters.
总体上现在我们感觉到这个空间很舒适，也很适用。
Totally, we think now the design rooms of our Tiangong space station is comfortable. It feels good.
还配有各种先进的设备仪器，可以进行大量的科学实验。
Also, there are many equipments in the space station. We can use them to do many experiments, research.
我们还有专门的中国的美食。
During special days like some holidays, birthdays, we have special surprise food, the Chinese traditional food, very delicious.
我在上面飞行6个多月时间，我的体重还增加了。
During my 6 missions in the space station, I didn't lose my weight. In fact, I get a little fat.
地面指使人员经常提醒我，不要吃太多。
Don't eat a lot. Don't eat so much. Just do exercise.
大家看到了，我现在又瘦下来了，回来又瘦。
Now well, you are always so handsome and slim.
我们乘组3个人都喜欢中国书法。
Coincidentally, all of us, all 3 crew members, we love calligraphies and we practice them.
这个用中国的字讲就是龙马精神。
Well, dragon and horse and our spirit and power, just like a dragon and horse, because Chinese have the tradition like I'm sorry, I don't know how to translate this.
因为我们3个人 正好2个属马，1个属龙。
Two of my crew
2个
members.
属龙，1个属马。
Two of my crew members were born in Dragon year, and the other one was born in Horse year. So I wrote this calligraphy just make this special memory reminiscence.
这个字是我写的。
I wrote it. It is pretty good. I just said this.
中国书法不太好写，我练习了将近20年。
The Chinese calligraphy is really not easy. I practiced for like 20 years.
我还在上大学的时候开始练的书法。
When I was a freshman in the college.
同样是在今年，中国公布了载人登月的初步方案，计划于2030年前实现登月并开展科学探索。
Although in this year, China announced the plan of manned lunar mission, this plan, and we are scheduled to realize the manned lunar landing before 2030.
我们期待能够亲自见证、参与我们中国人的登月计划。我想那一天一定是飞天之路当中最为灿烂的时刻。
We are looking forward to participate and witness the lunar landing, and I think it must be the most spectacular moment for space exploration, not only for Chinese but also for all of the world.
在未来浩瀚的太空必将留下更多更远中国人探索太空的光辉足迹。我们也欢迎在座的咱们志同道合的朋友们能够合作携手共创人类美好的未来。
In the future, I think there will more footprint of Chinese, but also I'm so welcome all the people have the same goal to cooperate with us and create a better future for humanity.
女士们、先生们、朋友们
Ladies, gentlemen, friends.
太空探索有目至今，中国愿意同各国一道加强合作，共同探索宇宙奥秘，和平利用外太空。
Space exploration is endless. China wishes to strengthen exchanges for the mystery of the universe, makes peacefully utilization of outer space, and promotes the space technology to benefit all the people together with other countries.
探索太空是人类的共同事业，让我们携手发展航天事业，造福全人类。谢谢。
Space is a common goal of humanity. Let's build the community with share the future together and to explore the space course for the benefits of the humanity. Thank you.
谢谢。
谢谢你，费学忠，
谢谢，
非常说的，非常好说的。I think there are questions. There are probably more questions than we have time, but let's go. It's such an interesting topic. And okay, so again, you have the very first question. Do you have any difficulties painting, calligraphing the hieroglyphs because ink behaves another way in weightlessness?
Pardon?
Did you have any difficulties making calligraphs in weightlessness because ink behaves in other way than in gravity, or special ink or special technique?
他问，就是中国书法在这么难，你在天上练的时候有什么技巧、什么诀窍？而且他知道的中国还有一些很厉害的，比方说雕刻，你有没有考虑去练一练？
雕刻我没练过，但是我可以告诉你，我学会中国的剪纸，而且是会编，叫什么？手串和项链似的那样。
First, I'm so sorry for my poor spoken English. Second, I should say Mr. Fei is very honest because at the beginning of the presentation, he just threw up the hand script, just say everything from his heart. So I think we should applaud for him. Third, I want to answer your question, and Mr. Fei said, yes, you're right. It is not easy to practice calligraphy in the universe. And he just practice one time by one time. And besides this, he tried to do some very dedicated things like use some special stone and lines to make a how to speak bracelet. Yes, bracelet and necklace, and just like the Chinese traditional things, very beautiful. Thank you.
Okay, before I come to you, I also want to ask a question about daily life on board. It's like, can you explain us a little bit how the daily life is? How many hours of sports do you do? Do you feel it is efficient to do sports the way you do it? And so also like how your week is scheduled. Is it like similar to ISS, or do you go for a different operational approach?
他问您就是一天做的运动量是多少，一周是多少，是不是跟空间站一样？
我现在回来以后，基本上和空间站差不多，因为我现在的运动量基本上达到了飞行前的状态。每天的运动量。
Yes, the daily exercise just like the ISS. And when Mr. Fei returned on Earth, his health and his personal feeling just like before. So similar.
Okay, then we have in the middle a question.
你好.
你好.
I'm curious about your commercial plans. For example, do you plan to fly astronauts from other countries? Do you plan to fly commercial astronauts? And in China, there is a rapidly growing commercial launch market. Will they be incorporated into the Chinese plan?
他说中国商业航天发展非常的快，您对此的看法是什么？然后您是否有考虑为商业航天来进行过一些工作？
因为我们目前的商业航天和我们这个民用航天可能还有一段距离。我不知道您说的商业航天指的是实际上的，就像某个人或者是需要像游客一样去。但是我觉得现在我们还没有具体到这一步，因为毕竟，一方面我们跟他们还不是一个单位，不是一个部门，因为我们还是属于没有具体到这一步。
As I know, Chinese commercial space station is just at the beginning, and I'm sure it will have a very good prosperity. But now I'm very good at enjoying my space career, so I haven't think about this.
不过我想，如果您或者您的朋友如果有兴趣，如果愿意到中国空间站进行旅游观光，我相信会有那一天。
And as I know, the space gust, right? The space gust is like a kind of commercial space aviation. So if you and your friends want to go to China and have this problem, have this idea, and I think it's a very good idea.
我一定促成您的想法。
I do my work to help you make your dream come true.
So we have more questions in the back.
Can you tell us where on the moon, if you know, your moon landing might be and what the goals once you're on the surface might be? It may not be determined, and I understand if that's the case. And also your lander, how many people will the lander hold when you first land on the moon?
问您知不知道以后咱们在太月亮的哪边着陆？什么时候着陆？着陆几个人？
不好意思，因为我刚刚回来，还没接触这个领域，我可能这个还停留在我刚刚飞行回来的这个经历当中。要不这样，我回去再打听一下。
I'm so sorry. I just returned from on orbit mission. And in fact, I'm really excited. I want to join to the lunar mission. So if I have the chance to attend the Chinese lunar mission, I'll tell you.
Okay, do you have one more question? There have been numerous emergencies on the Mir space station and some on the International Space Station. On the Tiangong, did you have to handle any emergencies so far?
.我不知道您提的说的是紧急事指的是什么级别？因为在我们飞行当中，紧急事件是分好几级，这个可能在座的航天员都知道。这个航天警告是分几级的，那么可能普通告警的事件是有过的，啊，但是再往上的事件，很抱歉，我这次没遇到。我相信没有遇到是好事。
I think for all astronauts and space researchers, we know that the space agency could be divided into several ranks, several levels. And of course, when I were in the space station, I faced some emergency, but they are in low rank, low levels. The top level, last mission I haven't met. But thank goodness, I think I and my friends, we don't want to meet this. Thank you.
And then we also had a last question. It's like before China had short duration missions, and now you're going to the space station and going to long duration missions. So, and from the ISS program, like coming from the shuttle to ISS, there was a lot to be learned. And so, what are the major challenges that you see now on the Chinese space station that you still need to, let me say, to improve, to learn, to master this change from short duration to long duration?
从短期到长期，从单人到无人，然后我们面对了很多挑战，我们学到了很多。那您认为在整个咱们航天的发展过程中，我们学到了什么？我们提高了什么？
谢谢啊，马加尔斯这个问题。我想探索者协会之所以要举行我们这样的一个会议，根本就是要探索我们航天员在飞行当中所经历的事，所经历事给我们的一些启示。
First, second, Matthias, it's a very good question. I'm so grateful to our Planetary Congress give us, especially our taikonauts, astronauts, cosmonauts, an opportunity to share our real experience in space. We can use this platform to talk about the things just like the emergency, like some interesting things, like some like maybe dangerous not happened, but maybe in the future we having ourselves.
正因为太空探索有好多不确定的因素，有好多未知，外太空我们还没有未知，还没有完全的了解，所以我们要不停脚步的去探索。
As the unknown trace of outer space, so we need to explore, we need to research, especially we need to cooperate together.
所以刚才马蒂亚斯你问我，我们从一人到多人，一天到多天，从几天到几个月，半年，甚至今后会有1年。我想更多的航天员不停脚步的就往前，不停的去追探索。我想更多的就是为了要为人类去造福。我们人类不可能永远生活在地球上。
Pursue the dream of outer space is a dream for the whole humanity. Sorry. Not only the researchers, but also our astronauts. We do it just like the quote said. We never give up. We do things. When we see a problem, when we see a trouble, we solve one. We find one, we solve one. We never stop. Just like the moonlight, the Martians.
一句话，只要还有未来，我们就要去探索。
So I make the last conclusion. We explore for our future, for humans' future.
谢谢。
Thank you very much.
谢谢。
In the interest of time, I think we continue with the last talk, which will be mine. So, but I will have only 15 minutes. If you can bear like a short overrun before we at 4:30 have to leave for downtown visit. Is that okay, President?
Yes.
Good.
Bir konuşma daha var. Flaşı çıkardı.
Okay, so this talk was actually foreseen for Thursday. It's a short update on what is new at ESA. And so I would like to take this opportunity to introduce you still today. My name is Matthias Maurer, as was mentioned before, and I flew with the fabulous crewmates that presented Expedition 65, 66, 67 up here. During my time I had like one EVA, and at the moment I'm responsible for the LUNA, the Moon Training Facility project, which I will introduce in a bit, also for Solaris, which is the space-based solar power project of ESA, and I'm also the deputy head of the European Astronaut Center. Last year, ESA selected a new class of astronauts. All those here that you see in blue circles were selected as career astronauts. Then you also see the others that are not in the blue circle. They are on a reserve list, so are reserve astronauts. And among the reserve astronauts, 2 have already been selected for a short duration flight, or Axiom 3 mission. Markus Wandt was already set, and also Swarosh, he will fly on one of the future missions. And then we have John McFall, he's in the yellow circle. He is part of our fly study. The fly study aims at flying a person with a handicap. So he basically is missing a lower limb on one of his legs. It was due to an accident. But he's also a Paralympic participant, and he runs faster than the rest of the corps. So just to tell you. And we're hoping also to get more flights of our other reserve astronauts. So let's see what is about to come. One of the topics among ESA was also Revolution Space. Revolution Space aims at promoting the idea of having human spaceflight capability also in Europe. There was a high-level advisory group that consulted ESA and said, like, we need to invest in human spaceflight. And not to act is actually, like, it's more expensive, even if it is expensive. Not to act will be more expensive than not doing anything. Unfortunately, it doesn't look like as if human spaceflight in Europe is coming soon. So it's being presented to the governments in Europe, but the economic situation at the moment is not in favor of that one. But we still keep on pushing. Then, small accident. Then we have also decided on investing in lunar exploration. There is a moon lander that was decided on the last Ministerial Council last year. Basically, ESA will provide a lander that has a capability of, in the end, coming to almost 2 tons of payload that can be landed, not returned, only landing on the moon. And the first flight is foreseen for around 2030, and that will be one of the contributions that Europe will put into the Artemis program to deliver cargo to the surface of the moon. And there's a landing module, and there are 2 cargo slots, one on top and one also on the bottom. And we also have foreseen an interface for EVAs in case that the lander lands in an area where also there's some crew. Otherwise, it can also be fully autonomous. Now, I would like to come over to present and introduce our new moon training facility, which is called Luna. So we want to prepare for moon exploration. This lunar facility is being built currently at the European Astronaut Center, right opposite of the Astronaut Center that most of you will know. We decided to invest around 45 million euros into that one. It's a 50% DLR, 50% ESA project. And basically it aims to provide a technology and innovation that is needed for space, for moon surface operations, but also with potential for terrestrial spin-off. Training and operations, scientific research, and then also knowledge transfer to the industry. There's also a startup center associated to this lunar facility. Actually, it was one of the conditions to get the funding for it. So it will be a low barrier entry for users. Basically, it's for free for universities, and also it is for free to like anyone who has interest. The principle is it works like a picnic. So everybody brings something, and together we have all the instruments, the capabilities, and ESA and DLR provide the infrastructure. Since the building is currently in the design, in the construction phase, I give you a short scheme. So it's not only aiming at providing a training center for astronauts and spaceflight experts, but it's also an invitation for academia to come and bring their experiments. Because what we learned is very often an experiment is designed and the crew hasn't seen it or sees it very late. So there's a lot of potential that has been missed in the beginning of an experiment. So we would like to bring in all the academia and the young teams that develop hardware, and to basically in an early stage already make use of this facility. The output is obviously that we want to have a facility where we can develop the space hardware. It will be operating 365 days, 24 hours, more or less, if it's needed. And we also want to spin off what we learn to startups, engage with the public, and also like to have knowledge and science transfer. The facility, it is basically a hall that represents the moon surface, and then we have a small moon station where it can be the lander in the beginning, or it can also be a moon station later on, and then we have evolution of more buildings on the outside. So the main simulation features of the hall and of the facility are that we have moon dust regolith. It's the same chemical composition, the same size distribution that we had like for the Apollo missions. It's volcanic sand. Then when we have illumination, basically the light can go down as low as on the horizon from 0 degrees to 90 degrees. To have also to investigate the effect of the shadows, because when we are landing on the South Pole, the light conditions will be very important. Interior of the hall will be painted completely in black to avoid reflections. So we believe it's very, very important to have as precise light conditions in the hall as we will have on the moon. We will have gravity offloading system, and a system that is a little bit different to the Argo system or other systems that are being discussed. We can offload at least 2 participants at the same time, maybe even more. And we have it fully embedded in the ISS ground system network, so we can have Houston remotely connected, we have the Columbus Control Center remotely connected, and obviously also a local control center. So some details on sand and on the testbed area. It's a 700 square meters surface. Most of the area is 60 centimeters deep, but we also have a deep floor area, 3 meters deep, and there we can bury samples, like frozen water samples. So when we want to go prospect and test equipment that finds water ice, which is buried below the surface, we can reshape the surface to have a realistic moon surface scenario. We have a ramp to test different inclinations for astronauts and rover mobility, also to test like the different procedures depending on a different inclination, also rescue scenarios. We will have representative rocks for the different areas on the moon. So basically Maurer rocks, highland rocks, and impact crater geology. It's for geology training, but also for testing, instrumentation, and procedures. We have relevant testbed size to place like Artemis infrastructure in there, and that is one of our goals, to be able to run an entire Artemis mission from the moment the Eagle has landed until the Eagle leaves again, or whatever will be the name of the Eagle. And also to house robotic systems, rovers, manipulators, and so on. And a separate dust chamber will allow us to focus on dust mitigation techniques, to check out all the equipment, see okay what kind of protocol is good enough to avoid that we can bring dust into the internal part of our spacecraft. So this is roughly the size of the hall, and that is the deep floor area and the dust lab. The sun simulation is mentioned from 0 to 90 degrees. It's adjustable, fully focused, to have the most realistic lighting conditions. It minimizes reflections and light scattering. Everything is painted pitch black in the internal part of the hall. So it will provide the best and the most realistic conditions for EVA training. And we also want to combine hardware and XR, so like augmented reality or virtual reality tools in combination for the hardware that we don't have available. So that we want to use to create the best conditions for visual navigation and also for self-localization of system and rovers and testing all these. Gravity offloading. These system that we have is basically a suspension system with cables on the roof, and the innovative part is that on the roof there will be small crawlers that allow us to crawl. We'll have many more gravity offloading systems running at the same time, and also to interact between each other. So the offloading is between 20 to 350 kilograms with a lateral speed of 5 meters per second, vertical speed up to 3 meters per second, and a stroke of 6 meters and more. So that should cover most of the scenarios that like the operations specialists want to test, and we hope that this is like already available by the end of next year. An important part also to our speakers from Axiom and Collins Aerospace and whoever is interested in providing spacesuits, we want to make the system compatible with your suits, and we are open to house your suits and your equipment to test it in our environment. The operation and utilization, it will be fully embedded into the ISS ground network. So it has all the data links, data sharing that we have currently from the Columbus Control Center to Houston. And basically, if there's a scenario that you want to run from Houston, you want to land on the moon in Cologne, you can do this. It will be fully embedded. We will have some facilities like mock-ups in real, but others can be added also on short notice on XR, augmented reality, and that is really a very interesting upgrade to the way we do currently training. One of the modules that will be already attached to the outside is the Eden Luna. It's a greenhouse that has spent, I believe, more than a year in Antarctica. It's currently being refurbished in Bremen, in the northern part of Germany, and being transferred to the lunar side. So this is one of the external modules that I mentioned initially. We foresee that we will not only have crew quarters, but also additional like science and habitation. We will have a greenhouse and other functional external modules. So it's like a small moon village that can be adapted according to the needs. That was a month ago. By the end of May next year, the hall will be standing, and then we will fill it with sand. So basically starting after the summer break next year, early operations will be possible, full operations in 25. Okay, and that's again the overview. So it's a technology platform, an operations platform. We can test science and integrated training. We have a mission simulation of end-to-end missions, and it will also be used for outreach and education. Especially for the Artemis program, and that's my pitch to my dear friends from Houston, we think Luna will be the best analog that is existing worldwide, and we want to bring it into the Artemis program to offer de-risking or testing procedures that currently cannot be tested in such a similar or high quality environment. We believe we can do everything what will be needed for the first phase of the Artemis program with like 6.5 days surface surface time on the moon, but also the phase 2 when we go for construction on the moon. I think we can offer quite a bit. Okay, so, and that is more or less already the last slide that I have. The utilization scenarios in Luna is end-to-end missions, de-risking, and also testing of infrastructure. And I think that will be the focus of the very first Artemis mission. Activities like ingress, egress, EVA simulation, training, surface preparation, deployment of hardware, transportation of hardware, assembly, manipulation, maintenance of different hardware items. Also later on in the stage to construct using local resources, and how to handle the dust and to mitigate bringing the dust inside. The science-related scenarios focus on local traverses. So we will not do all the running between the sites, but we can actually do all the science
focus part, like which samples to take and how to train for it, and also the operational interaction between the ground teams and the astronauts on the ground. One of the areas we are already quite advanced is the handheld instrumentation. So we have currently some nice projects running there. It's a handheld device that integrates several different techniques that are currently not available in Earth applications, and I think that's also something that we want to bring into the Artemis world. All right, that's the end of my talk. I'm available for short questions, but it's already 4:15, and I think the bus to town leaves in 15 minutes. So, okay, thank you.
You and I have many questions to you, but we can ask him on the bus. As he said, bus are leaving in 15 minutes. Enjoy the city, okay? Our return will be at 8 o'clock from the same point. If you want to stay in the city, you can turn on